Hey guys, this is Dr. Aeronautics. Today I'm going to be showing you how to create grayscale height maps that you can then import to Dwarf Fortress, and you can also import to WorldPainter so that you can actually create Minecraft maps of this. So just a little bit of introduction. Dwarf Fortress is sort of a simulated world game. It includes legends and historical events and other crazy stuff, so you can throw it any terrain you want, real or imaginary, or have it generate terrain by itself, sort of like Minecraft does, procedurally generated. And it will have all sorts of random history with dwarves, humans, elves, goblins, and a bunch of other stuff that you would find in Tolkien's literature. And yeah, you can basically have an entire simulated civilization, or groups of civilizations even. It's really almost limitless. There's like 70,000 creatures or whatever that can either spawn or not. Not every creature is in every world. I don't think any one world has all creatures, etc. So you can basically define it any way you want. And as far as Minecraft goes, if you don't know what Minecraft is, just look it up, Google it in videos. Basically, you can create a three-dimensional first perspective world that is 1 by 1 meter. So in our case, if you want to make an entire world in Minecraft, you're going to have to downscale a little bit. That's the only way that you can create a world, because you are limited to 256 meters. If the world height were higher, there would be no limit to, well, the limit of how big you can make a Minecraft world is approximately equivalent to the surface area of the planet Uranus, which is 4 times the diameter of Earth. So yeah, there you go. You can make basically any super Earth in Minecraft, but you're limited to 256 meters. So in order to make it realistic in appearance, you need to downscale, or rather upscale your Y height, and say something like, okay, 1 meter is going to represent 200 meters or something like that. That's the only real way to do it. So I'm going to kind of rush through this because there's a lot to do, and this has the potential to be like an 8-hour video if I don't rush through it. I'm going to try and be as concise as I can, and then we'll go from there. Okay, so the first step is to download the Lazy Noob Pack. That's if you want to do, if you would like to do Dwarf Fortress. You can also do Minecraft if you want to, but it's real easy. Here is a wiki on the Lazy Noob Pack so you can understand what you're getting. You go to the Bay 12 forums, that's the trusted site for it, and it's right here. The Lazy Noob Pack gives you a bunch of visualization tools that you can get for Dwarf Fortress as well, so it's extremely important. Now, I know this says Slaves to Armok, God of Blood, Chapter 2, Dwarf Fortress. That's the full name of the game, but most people just call it Dwarf Fortress. Okay. So let's go back here. Once that's downloaded and installed, you can begin. You won't be doing anything with Dwarf Fortress for a little bit. Other ways, you know, if you want to get Minecraft, you just Google it and download it from, I think it's Microsoft now. It used to be Mojang, and I think they sold it off. Okay, so the first thing we're going to do is define a region of interest. So let's open Google Earth. If you don't have Google Earth, you can use a site that you can pick latitude and longitude with a cursor. So you can go anywhere here. I must note my approach does not work well for the Arctic and Antarctic. So if you wanted something near the pole, that's what you would have to get. We're gonna go for an area that's not there. So in fact, what we're going to do is pull a swath of the largest estuary in the United States, the Chesapeake Bay. And we're also going to pick its sister Delaware Bay because it's kind of in the same area. So step by step, find the northernmost latitude. Okay. So in addition to just the bay, I want to include the entire watershed. Now that's going to greatly increase the size because the watershed for the Chesapeake Bay is titanic. You follow up the Susquehanna River, which is the chief river of the system and the longest on the east coast. You're going to get all the way up to right here at Sago Lake. So this right here is the headwaters of the Chesapeake Bay watershed. So we need a maximum latitude, and in fact for this it might be better off going to the World Hydro base map. Okay, here we go. Perfect. So all we need to do is just get the maximum latitude of the entire system. Because this is the headwaters of the Delaware, or not the Delaware, the Susquehanna. But funny enough, we're also going to get the headwaters of the Delaware because the two rivers kind of complement each other as they flow downwards. Okay, so let's get the maximum latitude here. Shoot, let's go to location here and pop right there. Okay, so we want this dot. So we have 42,988. Oh, that's so close. You know what? Let's just do 43 dot dot dot. Perfect. That makes things a lot easier for us. Okay, now we got to find the southernmost latitude. So Chesapeake Bay watershed pretty much ends as soon as you get to the North Carolina border. So that's a nice way to do it. Unfortunately, it doesn't end precisely on a parallel, so we're gonna have to get a latitude and longitude because it's not. Some of these like Western states, for example, will end in an exact parallel. Like for example, the northern border of the United States with Canada is at 49 north precisely. So that would work in that instance, but in our state it will not. So we're going to go down to right here, and we're going to get 36,550, and that would be close enough. Okay. So now if you want to send this to Dwarf Fortress, you need to get an aspect ratio involving these numbers. So we're going to see what we can do there. The Chesapeake Bay watershed is further north-south than it is east-west. So I'm going to try and get a 2-to-1, but we'll go to 1-to-1 if we have to. So if needed, we might have to find the distance between the latitudes. We're going to use the polar radius, which is 40,008 kilometers, and then we have to multiply that by 2 pi to get a circumference, and then we have to divide that by 360, and we should get something like 111 kilometers or something like that. Okay, I did something wrong. Divide by 360 degrees. Let's see, 40,008. Oh, hang on a second. That's a circumference. So forget all this 2 pi stuff. There we go, 111. Perfect. Okay, so that's the distance between every one of our lines of latitude. So we want to calculate the y range. So now we're going to just subtract here and then multiply by this y value, and then we're gonna find the map north-south dimension in kilometers. So it's 716 kilometers from the north to the south. If it's desired, we can find the midpoint here. I am going to subtract just like this, and then divide by 2, and then add the southerly latitude. So the midpoint is 39.79 or 77, which is about the Pennsylvania-Maryland border, also known as the Mason-Dixon line. Yeah, that's right about here. So that's our midpoint in latitude. Okay, next is to calculate the distance between the longitudes. Although, yeah, we can do that. Okay, so in this case, we need to use our central midpoint latitude in order to get this correct. So what we're going to do is take the cosine of this converted to radians and multiply that by the Earth's circumference, and this time we're going to use the polar circumference, which is going to be 6378 kilometers times 2 times pi, because we started from a radius there. So then we got the circumference multiplied by the cosine of our latitude, converted to radians, and then we just divide the entire thing by 360. And so we get about 85 kilometers between lines of longitude. That looks right. We're going to not do this, and instead we're going to find the easternmost and westernmost longitudes. So a convenient location to use is the DEM boundary, which I'm going to talk about a little bit later. That is somewhere around here. So we're just going to arbitrarily put negative 74.5. And we're going to explain what that number means a little bit later. And the next thing we're going to need to do is find the westernmost longitude. So let's head west. And the westernmost of the Chesapeake Bay watershed is going to be right here at the headwaters of the James River. Now, it'd be nice too if I could get the westernmost border of Pennsylvania, and it looks like that is actually going to happen. Yeah, I can get away with that. So let's use the western border of Pennsylvania as the example here, and that seems to be about 81.5. Actually, it's negative 80.52. Okay, so now what we can do is we can find this out here. So we're going to need to subtract 74 minus 80, and then multiply by the distance between them here. And now we get a dimension of 515, which is a little unfortunate. That exceeds our 2-to-1 ratio. So if we wanted a 2-to-1 ratio, we're going to need something about 3/5 of that value. So if I line this up, is this going to... No, it's not going to move. Okay. So we've got everything between where my cursor is now and the western edge of the screen. So if we go 3/5 of that way, oh yeah, that's going to put us in... yeah. That's going to cut off the majority of the James River watershed. That's a little bit too bad. So we're going to have to go to 1-to-1. So if we go to 1-to-1, we're going to fix the eastern border, and we're just going to keep going west until I am satisfied. So let's play around a little bit. We need to match 716.81. So let's do negative 8.5. That's too big. Negative 8.3. We're at 727. Okay, getting really close. Let's try negative 82.8. Okay, 710. Try negative 82.85. We're at 714. Try negative 82.86. 715. Negative 82.87. Okay, there's 716. Negative 82.878. And I'll call that 1-to-1. So what I just did was I mapped the longitude range with the latitude range, and that was necessary in order to get the map to be able to go into Dwarf Fortress. You have to be able to use these aspect ratios here. Otherwise, you know, it just doesn't work. I want to use 257 because I want the map to be as big as possible. and the next thing under that is 129, and that just doesn't work because it's a 2 to 1. Okay, so I've got our dimensions now. So the next step is to go to this Sagire site is what I call it, but I'm sure it has a fancier name, something like that. So here you go. This is what you get. We're going to do data selection method import coordinates. That's that one right there. And now we're going to plug our numbers in. So let's jam this up against here. Actually, that won't work. Never mind. Okay, so our minimum latitude is 36.55. Latitude min 36.55. Our maximum latitude is going to be 43, exactly. Okay, now you have to be careful about this. Your minimum latitude, that's going to be your westernmost, because we're negative here. And that's going to be negative 82.878. Negative 82.878. Okay. And that will only take 2 digits. So to ensure that we don't get cut off, I'm going to round it up to negative 88. Okay? And then the eastern is going to be about negative 74.5. And this is where the DEM boundary comes in. So every single one of these boxes here represents a downloadable image. And the idea is you want to try and minimize the amount of downloadable images you get because it makes it easier to stitch things together when you're done. So what we're doing here is we're picking an eastern border here so that we don't have to worry about including these DEMs because we're going to cut like 90% of it out. So we're just not going to include it at all, period. Okay, so we've got those numbers plugged in. And now we're going to click the search, and then we have to download everything that's displayed. So click search, and we should get 4 results. Yes. So we've got a lower left, a lower right, an upper right, and an upper left. So I've already got upper right and upper left, or upper right and lower right. So now I'm going to download these guys. Let's see if I remember how to do this. You want the data download HTTP option. So I've extracted all 4 DEMs. Now I have another DEM too, this one. And I'm going to explain that a little bit later. But it is important for me that I download this one. So I'm not going to that one because it varies where to get these. I mean, depending on what you're looking for, there's no one website where it's all displayed. So we'll get into that a little bit later. Okay. Let's see, we've extracted everything. So now you're going to need a special program called MicroDem. You go to that URL, you will be able to download MicroDem, which is a very powerful DEM manipulation tool that you will use to build the grayscale height maps that will be used to generate the terrain. And the terrain is everything, because the terrain can tell your mind where certain things are. Like, for example, if you give me a terrain map in grayscale, I can tell exactly where the Atlantic Ocean is. I can tell exactly where Pennsylvania is. I can tell exactly where West Virginia is. That sort of thing. So you just download the complete MicroDem install. It'll set up. It's a very old program, so don't be alarmed when it starts looking weird. But it's fine. It's safe, and it's very fun to use if you know how to use it. So let's see. Next, we're going to open MicroDem. So you double-click it, and it should open right up. There we go. So this is MicroDem without any data loaded in it. Let's open every DEM we have. So that's File, Open, Open DEM. And let's go back out to 2004. And now it's going to open that dem. Okay. And okay, we've got the Great Lakes, so that's exactly where I want it. And now we're going to open the next dem, 2005, and see what we get here. Okay, now we've got the Southwest, so I'm going to stick this guy down here. Let's open the next dem. So that should be 2104. Okay, and that's our northeastern dem, so I'm going to stick that guy up there. Okay, and there is our southeast. So it looks like we are going to get a little bit of the Delaware watershed cut off, but that's too bad. We can't really do anything about that. So we're going to stick that here. Okay. Next, we're going to have to start subsetting the dems. If you're very near to the pole, you can have longitude creep. And let me demonstrate what I'm talking about. So if we start going towards the north end of the Earth, you're going to get severe distortion. Like if you wanted to do Greenland, this is not the shape of Greenland at all. If this were the case, then it would say essentially Greenland is shaped like a shield or a triangle, which it's not. Let's go to earth.nullschool.net and look at it in the genuine, and it's not. It's shaped more like a rectangle. So that's a big problem that you can run into. So let's go to the northeastern dem here and look at the very last coordinate at the lower corner here, the southern corner. So the smallest latitude that we have is negative 75.01. Okay, so we're not going to include as much eastern as I thought. So what that means is we now need to adjust our western border. So what I'm going to do now is I'm going to fix this so it's 1-to-1. And to do that, we're going to go negative 74.5. This is now going to become negative 75. And now we need to go back half a degree. So it's going to be, let's see, 378. Negative 83.378. And just to confirm, yes, negative 716. So I'm going to make the changes on my notes here. It's going to be negative 83.38. Now what we're going to have to do is we're going to have to check our western dem and make sure it goes that far west. Yeah, it goes out to 85 degrees, so we're fine. Okay, so now we need to start subsetting dems. Now before I go any further, let me show you about something that you might be dealing with. Your dems might look like this. I think they also have something like, let's see, grids, might have legends and whatnot. Yeah, something like that. You're going to want to take these off before you start manipulating them because it could cause a problem. But before you take off the elevation one, note which dem has your highest terrain. And if you don't have sea level, which one has your lowest terrain. Because this terrain has the open ocean, we know that this one definitely has the lowest. But this is the highest right here. So Z highest is 20_05, and Z lowest is going to be 21_05. That's important for getting the heights correct. Now you're going to right click on the dem, do grid, select neither, click OK. Right click again, do legends, uncheck elevations, okay. So that will leave you without anything to mess you up. Let's begin subsetting. So you need the northeastern corner. For here it's easy. So we need to go out to negative 83.38. And that's right about there. Get as close as you can. You won't get exact. We'll have to trim it down later. And you want to go to 43 north. So 43 right there. 002, I'm going to memorize that. And 38161 to memorize that. 38161, 002. 38161, 002. Perfect. Click and hold. Drag to the southeastern corner. And then release. Okay. So I've now subset this dem. This is the section of land that we're actually going to use in game, if you will. Okay. Now for this one it's easy. We're using the entire latitude longitude range of this dem. So the only thing that we're doing is subsetting below the 43rd parallel. Now this is extremely important. You need to drag from the northwest to the southeast. If you pick any other corner, the subset will not work. Let's go to 43002 right there. Okay, I'm going to cut this off because you probably get the idea. We're going to repeat this for all 4 dems. Okay, it's extremely important that when you do this, you pick just outside absolute terms, like, in other words, just further south of the southernmost point, just further east of the easternmost point, because we're going to trim it once we get it into an image editor. Now, this is what I was talking about with the north-south issue. It's wider in the north than it is in the south, and that's because the Earth is a circle, so that's what happens if you try and use squares to represent a circle. Okay, so once you get it together, it should look smooth. Here's Lake Ontario. That looks good. And you can see the Susquehanna River Valley. And those two kind of meet. Yes, the coloration's off. We're going to fix that. But you can see this is a river valley right here. And that matches up very nicely. You want to check here. Perfect. The river goes together. And here, yep, another river. And now we can find a mountain range between here and here, between here and here. The next thing you want to do is check all the borders. So you want to make sure we got everything. So I'm going to spread these out just a bit. And we want to make sure that there's no gap. So here we go off at negative 80. And we come on at negative 80, which is what we want. Here we go off at negative, or at 0.6, 0.6. Check these parameters here. That goes off at 0.0, 0.0. Okay. Perfect. And then the last thing is 77,992. Actually, I did get 80 there. And this one comes on at 80,008. Okay. So that looks good. That looks like we have everything now. Okay, so we're at the fun part now. So this is where we start changing the elevation to be what it is. So now we need all the dems open. I told you that there was a 5th dem, and I'm going to bring that up now. So I'd mentioned that we have ocean. And there's another thing that we have in here, and that is the Chesapeake Bay, which is connected to the ocean. So the Atlantic Ocean is basically a uniform, basically a featureless plain with a uniform slope. So it's pretty easy to recreate all the land sloping away. But one thing that's not particularly in that sort is the Chesapeake Bay. That kind of follows a canyon aspect to it. So in order to get more realistic, I actually have found a Chesapeake Bay dem. and it varies the sites that you get to them, but generally if you just search bathymetry, there's probably a DEM for Lake Ontario. Okay, so good news and a little bit of bad news. The good news is I was able to find a bathymetric map. Now, I got the name wrong. It's not Ontario. It's Erie. But anyway, the disadvantage is they are using a different datum, which means I have to see if we can do a datum shift, and if not, then we're going to have to paste this in using image manipulation later. They use the surface of the lake as the zero elevation here. And that's an issue because the actual elevation of Lake Erie is not sea level. It's let's see if there's a surface elevation somewhere here. It's probably about 600 feet or so. Oh, there we go. 569 feet. Yeah, that's what I figured. So we're gonna have to see if we can do a shift, and if we can't shift, then we're just gonna have to generate now. So let me try that. Okay, so fantastic news. I was able to perform a datum shift. So basically what I did was I went to edit and let's see, it was simple grid arithmetic, raise lower z values, and then I just added the level of the lake level on top of it. So now it's correctly displaying the deepest area is about 110 meters in elevation, and the lake surface is just about 170 so meters up. I might need to adjust that just a bit more, but that's exactly where I want it to be. So yeah, everything is looking good there, and we should be able to proceed now. So we are finally done. Everything is ready to come together now. Again, I'm checking to make sure that if I follow the Lake Erie coastline here, my cursor is going to appear. I did do a little bit of manipulation by accident when I turned off the legends here to this guy and this guy, but you don't need to worry. It's displayed the same regardless. It just appears differently, but it's the same data. So no worries at all. So now what we're going to do is we're going to take the elevations. So instead of doing calculate elevations extremes, we're actually going to do display parameter, because if you do calculate elevations extreme, if you subset any DEMs like we have here, it'll give you the entire DEM's worth of data, not the subset that we've chosen. So what I'm going to do is I'm going to mark on my paper the 6 DEMs, and we're going to record the highest and lowest elevations. And I'll include a couple flukes too. So right click display parameter elevation and just click Z range, and that will give us our maximum elevation, which is 517 in this case and 101. So that happened to be right with the total DEM. Hit cancel, because see, it'll select this by default, and now if we hit OK, it'll look the same as this. That's basically what happened. Okay, now we're going to go here, display parameter elevation, Z range. Okay, and this is example number 1. So we're going to have 776 for the max here, but that's definitely not right. That's almost as low as the Marianas Trench. So we're going to choose minimum instead, as we're only interested in this DEM where the lake is, so we're going to choose the minimum layer of the lake, which is 172 minus 64. It'll tell you, if you mouse over it here, what the elevation of the lake is. So you subtract 64, we should get 108, which is interesting. This DEM actually has lower regions than Lake Erie, which is kind of a bit strange. Okay, same thing, display parameter elevation, and now I want to call your attention to something that could be right, and it is. So the minimum here is negative 69 meters, and this region tends to have a lot of quarries. And 69 meters below sea level is a perfectly suitable altitude for the bottom of a quarry. So we're actually going to leave that. You can choose whether or not you want to include it. I would like to, because we have parts of the Atlantic Ocean and parts of the Chesapeake Bay. So we're already used to going below sea level. The only difference is we just won't fill that with water, except at maybe the bottom meter or two. So we'll just repeat this for the remaining three. Okay, so I've calculated everything, and now it says to choose the lowest minimum and the highest maximum. So let's see, all our data's over here. So the lowest minimum that I achieved was, not surprisingly, in this DEM right here, the Atlantic Ocean, probably somewhere in this vicinity, because the slope is away from the land here. If I hover over it, it won't tell me. Actually, you know what? The negative 85, that's probably a quarry. Somewhere up in this region is probably a quarry. But negative 85 meters for this region is probably acceptable as well. Chesapeake Bay minimum is negative 53 meters. So that is not going to be any further. So the bottom of the world is negative 85 meters. That's the absolute bottom. The highest altitude that we achieved was 1,738 meters. Probably right here. Yeah. In the actually, no, that's not it. But it's right here in the Appalachian Mountains. So the absolute top of the world is 1,738 meters. That gives us an entire range. So if I do display parameter elevation, we do grayscale, those are deselected good, and now we specify here the maximum is going to be 1738 and the minimum is going to be negative 85. Now if I check OK, that will mute some of the grayscale colors out, but that's exactly what we want. I'm going to do the same thing here. Display parameter elevation. We're going to go for grayscale, deselect lake and ocean check. The high is going to be 1738, and the minimum is going to be negative 85. And what this is going to do is it's going to put this one in the exact same coloration as this one here. So if I mouse my cursor over any particular location that's shared on both images, like for example right here, the colors should be exactly the same. So that's basically the deal. Now the difference between this one right here and this one over here is this one is going to show us below the level of Lake Erie, whereas this one's just going to be completely level. So what we're going to have to do is we're going to have to take this and sandwich it in here, which should be pretty easy. And then we're going to do the same over here. So if I do display parameter elevation, grayscale, deselect lake and ocean, 1738 and negative 85. Now when I put these side by side, they should look identical. Well, no, they should essentially buffer up to each other. So it should look smooth. And it does. So there should be no color difference between what you have on this side and what you have on this side. That shows you that you're building it correctly. And just like before, I'm going to do the exact same thing on these three DEMs. Okay, all together now. You stick them against each other and you should get a smooth image. This one we're going to need to move down just a little bit more, just to check and make sure that everything's where we need it. Now there's another thing that just occurred to me that we might have to address, and that is the Atlantic Ocean and Chesapeake Bay elevations. Now because Lake Erie is very smooth, there's no issue. But because the Chesapeake Bay has tons of like little rivers and stuff, in order to make sure that we get the shoreline accurate, we're gonna possibly have to fudge the elevation on the Chesapeake Bay, at least on its highest elevation. We might have to say immediately drop to 6 or 2 meters below sea level, depending on what the scale becomes. So yeah, this looks good. And you want to check and make sure that your lowest elevation is black, which is pretty much the Atlantic Ocean, and your highest elevation should be white, which it is here. So that looks good. Yep, everything looks good. So this is all going to stitch together as a single grayscale height map, which we're about to do now. So in the case of a shallow ocean, which is what we have, then we should be able to enter the RGB value as missing. So I'm going to take care of that right now. I just remembered. I probably want to display this on camera. So what we're doing now is we're going to color the Atlantic Ocean in such a way that it most definitely appears below the edge here. So what I'm going to do is, for missing data, which is where the water is, we're going to round down to the next nearest whole number, and then we're going to do 0 minus this number, negative 85, divided by the max minus the min, which is this guy minus that guy. Close the parentheses and multiply by 255. Enter 0 for a whole number, and we're going to get 11. So enter the RGB value as missing, missing, missing. Well, that's a little bit confusing in my terminology, but if I do display parameter elevation missing, that's pretty close, actually. You know what? I'm just going to leave it where it is, because that actually looks pretty good, to be honest. So it just doesn't show up, but I'm telling it to show up as sea level, basically. Okay, so I think we're good there. So for a deep ocean, we could set the missing to 0, and then it would be forced down to extremely deep depths. But that's not what the eastern seaboard looks like. You go here, let's see, save image, and you want BMP. I'm going to save these in grayscale tutorial. And let's see, did I grab, yeah, I grabbed Lake Erie first. Okay. So I'm just going to save that as LE because it kind of is different. This one won't even allow me to save, so we're going to do save. I'm not sure why I did that as image. Okay, and this one is 2004. Make sure you save it as a .bmp because that will preserve your cliffs. If you save it as a JPEG, you will not get any cliffs or mountains. You'll get hills and smooth areas. It will smooth out your mountain peaks. In fact, you know what? JPEG simulates erosion. So if we wanted to simulate what the Rocky Mountains are going to look like 15 million years from now, save a demo of the Rocky Mountains as a JPEG. And that will simulate erosion. Okay, so this is going to be 2104. Save as a .bmp. I'm just going to repeat this for these three as well. Okay, so we should have our base maps now. If I go back to the folder and just go ahead and take a look at them. Let's see, that's going to be the right What am I looking at? Okay, that's a top. That's a bottom. That's a top. Okay, that looks good. And top, bottom. So what I'm doing is I'm quickly flipping between them to make sure that they look even. And then I also saved Chesapeake Bay as CB and Lake Erie as LE. So that should be it. I think we're done in microdem now. And so now we have to begin the stitching process. So we need to open every dem that we have in an image editor and start pasting them into a master background. So depending on how large your dem is, you may have a memory warning or a memory issue. So yeah, let's see what the dimensions. The largest one I think is Lake Erie actually. We're gonna have to cut that down to size, but for now, oh yeah, that's just 1038. I hope these are resolute enough. We're losing a lot of resolution here. Oh man. Yeah. Shoot. Some of these passes aren't even appearing well. All right, let me take a look at a previous one to make sure that we're kind of in the size range of what we're expecting. Yeah, we are definitely there. We're gonna have to fix some of these problems in the WorldPainter. Yeah, Dwarf Fortress should be able to fix that when it starts running rivers, and it's pretty neat. Dwarf Fortress will be able to figure out exactly. It'll start springing. It'll start making springs. And these springs will find these river channels, and they will grow up to be huge rivers. So let's go ahead and get started now. Just right-click and do open with paint.net is my preferred image editor. You can use anything you want. I wouldn't suggest trying to use Paint because there's limitations. If you just search paint.net, it should work. It's free, so I highly recommend that one. Okay, so we need 1, 2, 3, 4, 5, and open. So what we're going to do is we're going to do open because we don't want to deal with multiple layers yet. And now what we're going to do is we're going to pick one of these to be ginormous. So we're going to need about 3 times the current size. Don't do resize. Do canvas size. And this image happens to be our lower right. So we're going to pick the lower right for expansion. And we're going to do percentage by 300. And we probably won't use all of that, but you know, kind of important. So I'm going to magic wand this and make sure you turn that tolerance down to 0%. We want to make sure that we're not deleting any part of the map here. You want to delete the extra space so that you have a pure canvas, because any white will mean instantaneous mountains to the maximum range permissible. Okay. The next thing we're going to do is we're going to start arranging these images. So we have 2105, and this is where we go back to the SRTM. Above 2105 is going to be 2104. So what we're going to do is we're going to go back here to the master image and look for 2104. That's that one there. And just Control A, Control C it to grab the entire thing, and Control V over here. And now what we're going to do is we're going to line up this corner because we did it per latitude. Now here's the thing, because you're dealing with the circular Earth, this is where you're going to start encountering problems. We're going to have to now deform this, and it will be permanently deformed from what you have before, and it is rather unfortunate, but this is what has to happen if you want to make a smooth image. Deselect, and you should not be able to tell where that border was. As long as that's the case, you're good to go. Okay, next I want to get our highest place on there. So to the west of the bay is going to be 20_05. So that's this guy. We're going to select and drop. And now I'm going to yank this down to the bottom. And we are sizing to the lower image. So because latitude is always not deformed in equirectangular, it's longitude, we shouldn't have to manipulate this image here. So I just want to look and make sure that everything looks good. I'm seeing a little bit of distortion, but if I look really hard, yeah, I really can't tell anything. Okay, that's acceptable for me. Let's go back here and fill in our final quadrant. The upper right is going to be 2004. So let's find 2004 and just Control-C it, Control-V, and same thing again, line it up just like that. We want to make sure it matches. Yes, it does. It matches height-wise. It always should because of how we build our maps. And now we're going to adjust the longitude. We're going to force it to be this one. And this one has some convenient north-south river channels that we can use to check our work. And now we should have a perfect square that's 2:1. And we should not be able to tell where those seams are. The only seams that I can find, believe it or not, are geological seams. Like here's the fall line of the eastern seaboard, or the Appalachian mountain ridges, or the edge of Lake Erie. This is good stuff. And just to confirm, if I go all the way up, we should be able to see... Oh, no. This concerns me now. Is Lake Otsego off of... we didn't include those last coordinates now. I really hope that we have Otsego Lake included here. No. Doggone it. That's unfortunate. So we actually don't have the headwaters of the Susquehanna River, which really stinks. But we get to the point where you've got small creeks. So let's go back. I don't think I'm willing to include an extra one just for that. I mean, you saw the amount of work that it takes. I'm just really not interested in completing it entirely. That might be a fix that I can do later. Oh. That's not good. That is bad. It is very bad. Okay, so somehow when I was making the save, I had a cursor that was here. So this would show up as a ginormous cross-shaped mountain. What actually it looked like a volcano because it'd have a crater in the middle. Okay, so we're gonna have to recapture. We're gonna have to recapture this one. Okay, it's gone. So we're good to go. Again, we're going to drag it down here, and we should not be able to tell where the borders of this thing are. Looks pretty good. Alright, so this is the full image here. What we're going to need to do now is make this image exactly 2:1. So what we're going to do is we're going to select the entire image now. And we have 1000 by 1036. So we need to... the image is taller than it is wide, which means we need to cut some down vertically. And we need to do 36 pixels. This kind of irritates me because we already have our headwaters cut off, and continuing this makes it even worse. So let's see what happens if I draw that down to over 1000 by 1000. Not too big an issue. Okay. I'm going to do it. So what we're going to do now is crop to selection. And now we've got a square 1000 by 1000. Some parts of the image were left behind. Unfortunately, like I said, we also don't have Otsego Lake, which really stinks. So that's the headwaters, but things happen. Okay, so now we can't export just yet because we need to get our Chesapeake Bay and Lake Erie images in here. So for that, I'm going to save this off as a different image. I think I'm saving. Saving as a bitmap. You always want to save as a bitmap. Yeah. Because that preserves things. If you start saving as a compressed image file format, you'll get a lot of weird stuff going on. Okay. So now we need to get our honored guests in here. I need to figure out what color the sea level of Lake Erie is, because we only care about what is darker than that. So to do that, we're going to go ahead and write this out here. We know that the surface of Lake Erie is 172 meters. We know that the bottom of the world is -85, and we know that the top of the world is 1738. So what we need to do is exactly this lake calculation, or the shallow ocean calculation we did up here, but with a slightly different number. So what we want to do is the lake elevation minus the bottom of the world divided by the top of the world minus the bottom of the world, and then multiply that by 255 and round up. So we'll get everything that's darker than 36 for the pixel value is what we're going to take. And just to check, let's see, it looks like the shore probably right about here. 36. Okay, that looks good. So now what we want to do is we're going to do levels here. I think that does it. So if I go down to about 36, that'll only give me Lake Erie. But the problem is then the image is incorrect. So here's what we're going to do. We're going to do this. Then what I want to do is I want to select there and there. Okay. And that should give us everything that's above the elevation of Lake Erie. Now I want to try and undo. Okay, undo's not going to work. Let's see if we can do this another way. So we're going to open another copy of the image. Now what I'm going to do is I'm going to select this, invert the selection so we get all of the water, then delete Lake Erie. We're going to add a new layer, put it below, and then we're going to grab the Lake Erie section, paste it, and that should give us what we want to see now. And so now what I'm going to do is I'm going to go back to this mode, going to select all, invert the selection. Now let's try crop to selection. Perfect. Okay, so now we've got a Lake Erie, and we're going to move that into here, and this is going to be pretty difficult because we're going to have to resize this until it looks right. So let's do keep canvas size here, and we're going to have to shrink, whoops, grab the wrong layer of the image. We need to grab layer 2. Okay, we have a giant Lake Erie, and now we need to make it more realistic. Okay, for this I'm going to need to add a layer. Okay, so what I did was I clipped to our northernmost and our westernmost location. So this dem can be shrunk using this corner, and all we should have to do is shrink it until there's no border between the south and the east side. So let's try accomplishing that. Okay, looks like right about there is where Lake Erie actually is. So I think we have a smooth Lake Erie in here now. Now here comes the hardest part of all. We have to get the Chesapeake Bay into here, and the relief on the Chesapeake Bay is next to nil. So it looks like sea level is about 10. So anything above 10 we need to chop. Okay. So what we're going to do now is we're going to select everything that's not the bay. I wasn't expecting that. I see. So it's because of missing data. Lovely. So that's going to greatly complicate things. So what I'm going to have to do now is I'm going to have to... Yeah, that is jacked up. I'm going to have to alter that down. Okay, so what I did was I changed the grayscale map to be white is 0 and black is the bottom of the Chesapeake Bay. So what I'm going to do is I'm going to have to do an image manipulation afterwards. So what I did was missing data is now colored black. And so what I'm going to do is delete it. So I selected all the shoreline, and that got rid of the mainland. But the Chesapeake Bay has a lot of islands, so I have to remove those islands now. And they will show up as islands. They will just be, what will happen is this will be a layer, just like Lake Erie, and this will get backlit by the layer that's there now. So any land will appear in these vacant pixels. But meanwhile, I have to get rid of them because to the system right now, they're going to show up as holes in the ground. So basically, we're going to go all the way to the deepest level possible, -85. So we're going to get rid of those, and then it should be backlit by what we have now to sea level. So I'm just going to finish clearing these things out, and then we'll come back. Okay, so I believe I've eliminated every island from the Chesapeake Bay now. So what we have to do now is figure out what our sea level is. We need our sea level value. Alright, we want background 10, 10, 10, 10. Okay. Sea level definitely looks like it's 10. And this is 12. Do we have an 11? Hoping we have something halfway in between. Because otherwise we're going to get, you know, like little cliffs. I want to make sure that we don't get little cliffs. Alright, let's try 0 tolerance on that. And that's going to be... That came up as 12? Or no, it didn't. That's what's 10. Let's see. Anything here a problem? Probably not. Okay. Let's recolor this from 10 to 11. So what we're going to do now is we're going to do paint bucket 11, 11, 11, paste. So now we should have just changed our sea level from 10 to 11. Let's see. 11, 11, 13. What in the world? Okay, 12. 12. Give me some water. 13. No. That might be water. Yeah, 11. Okay. Okay, so sea level is now 11. So now what we need to do is we need to go back to our map here, and we need to adjust levels here. And what we want to do is we want to take the whole image and we want to collapse it down to, let me see, 11 was, I think 11 was the first, 11 should be the first wet pixel. It's a bad place to use it. Let's try here. 11, 13, 12. Okay. Yeah, 11 is our first wet pixel. So the top of this image, should you adjust the levels? The top of the image, we're going to take the whole image, and the top should be 11. So we should end up with a very dark image. That looks good. Oh, but now if we go to 0, that's going to be negative 85. So now the next thing I need to do is figure out what the darkest spot should be here. So if I do 0, we should get, yep, 11. That's sea level. So negative 53 was the deepest in the bay. And that's going to show up as, we'll round down to 4. Just to get more... I call it a convenient rounding because there's only one hole in the Chesapeake Bay that gets close to that. I'm going to round, and that'll make it more expansive for everything. You know, it'll give you more variation. So we're going to round down to 4. And let's just check. The shallow areas should be lighter in color now, and the deeper areas should be darker in color. And that's right. Okay. So now I want to select... Actually, you know what? I just want to select the whole thing now. So let's do Control A, Control C. Now, this is going to be really tough. Going to add a layer now. And now I somehow have to get this thing down to size. Or up to size. Okay, so what I decided to do is I'm going to create a ghost Chesapeake Bay in between. So what we're going to do now is we're going to take this, move it over to something else, and now we're going to change the color curve to be an extremely bright color that I can recognize. Perfect. And so we just won't include this in the final version. This is kind of a last ditch attempt for me to kind of get this to work. So what we're going to do is we're going to set this down to 447. We're going to try and play it by math at first. And once we get to 447, we'll start making whatever manipulations we have to for this to work. Sometimes getting this detailed isn't necessary. If that's the case, you know, you can always skip this section if it doesn't seem to be very related to what you're doing. Like if you wanted to just make a mountain range, that's a lot simpler than trying to do something like this. I am really getting my hands dirty right now. But as long as I do it right, it should look really good when we're done. So I'm just going to keep coming up here every single time, realigning and realigning and constantly realigning. So what I'm doing is I'm actually picking certain landmarks that are showing up really good, and lowering a northeast, south, and west section until I stop doing that. And this happens because the landmark that I choose is never at the absolute northernmost or southernmost point. So there's always going to be a little bit of fighting going on until it gets correct. And eventually, it's kind of like numerical solutions. Eventually you will find a solution that just doesn't need manipulation, and it stops. You stop needing to move it. So for example, I'm going to look at the bounding rectangle size is 422. And if I come up with that again, yeah, now I got 421. If I come up with 422 again, then I know that I have a correct direction. Like east-west might be aligned right now because I don't see anything wrong with this. Let's go north again, and we're at 421 right now. We're getting really close. Still at 421. Okay, so we might have, and now I'm going to look at the width as 220. Let's try 221. I think this is probably close enough that we can fix it pretty easily in game. So we have the top selection top left is 706 by 541. Size is 222 by 421. Okay, so now what I'm going to do is I'm going to go back to this layer. I'm going to pick the real bay. Get our size, which is 222 by 421. Okay, and now align that with top left 706 541, and if I do that, I should not see any red. Not sure what's causing that. It's probably an artifact of the resize. Well, I think that's probably close enough. So now we turn layer 4 off because that's not what we want, and this is what we're left with. This is the actual overriding map of the bay, and I'm pretty happy with that. There's a few things that are just a little bit off, but I think we're going to settle for that. Yeah, I think I'm going to settle. When you get this big, it's just kind of really hard to get that to work all at once. So I'm going to save it just in case we need to back this out. But then I want to resave this as a .bmp. We trimmed the image, so we're good to go. For Dwarf Fortress, we now have to scale that image down, which is going to stink. We're going to lose a lot of accuracy here. So we need a .bmp. It's always a good idea to save out because once you override, it's done. And we definitely want to flatten. That gets rid of all the images. And it should be smooth now. Okay. So we'll worry about the depth of the ocean when we get into the editor. Or I guess I could do that now if we really wanted to. And the key is to not hit 0 beforehand. But we can take a look at this real quick. If we, oh my gosh, all my searching for Lake Erie. Let's see. A good place to go to would be NOAA Nautical Chart Catalog. And this number 3 would have one that we're looking for. So I think the best chart probably 12221. Okay, good. And let's see how far off the coast we are. We're about 2 Chesapeake Bay widths off. Chesapeake 1, definitely close to the corner. These depths are in feet, we'll have to convert to meters. Okay, so the highest I'm seeing here is 77, 85. Here's another 85. Yeah, I'm not seeing anything in excess of 90. That might be a 95. Okay. These are in feet again. So let's see, 95. We have to convert back now. Got 95 is going to be negative 29. Should get something around 6 or 7, I think. Okay, 8 actually. Yeah, see what I mean? The Atlantic is extremely shallow. So our sea level is actually 11. So we could actually paint these in right now. If I select the Atlantic sea level, Let's see, try and make this realistic border on this side. So we've got 10 down to 8. So we can paint 10 on this side. Let's magic wand 10. And now some of this, what I'm doing is a bit bogus. Like I'm just creating these contours. They're not actually simulated, but I'm only doing 10, 9, 8, and that's it. I'm literally just doing contours 10, 9, and 8. So it doesn't make much of a difference. So yeah, you basically just keep filling these in until you get down to the depth you want. Nothing much to see here. One good thing to get in the habit of is making like little brush streaks. That way this stuff will actually look a little bit more realistic and not cartoonish. So for natural effect, make sure that you use like jagged lines. And I know that the Chesapeake Bay gets shallower as soon as you go out to the ocean. So I'm just going to cut little jagged edges into the shoreline here. And you probably can't see this. I can barely see it. I'm literally looking at the difference between two layers of pixels. So in other words, a single brightness level, which is extremely difficult because there's like 8 million colors that you can create using the RGB palette, and for the human eye to be able to see that, it's really tough. Okay, I like this now. We're going to Control S to save this as a single image, and unfortunately now we're going to have to cut it down to a dimension in Dwarf Fortress, but don't worry, it'll build it up again. As long as you've got the major hills there, it will be able to figure out where things are supposed to go. So let's go down to 257. I'm going to save this as Dwarf Fortress because I don't want to lose the Minecraft scale that I've developed here. And now what we're going to do is we're going to resize to 257 by 257. And just confirm. Yep, 257. Okay. And this is what we're plugging into Dwarf Fortress. So yeah, it looks like it's cut down a lot, but trust me, it'll figure it out. Dwarf Fortress will find these river channels and realize that it has to erode them in order to get through. It'll figure it out. Okay. Well, we're getting down to the end now. So let's see. PerfectWorld is Dwarf Fortress. So let's continue down the Dwarf Fortress path first, and then we'll go down the Minecraft path second. Okay, so in Dwarf Fortress, you now need to back up the world starter file, because if you don't, the PerfectWorld will manipulate the worldgen.txt file, and it's a good idea to just save a copy of that off. It looks like I've already done this. So once you've done that, then you can begin by opening PerfectWorld. So we'll open the starter launcher now. Okay. When that comes up, you go to Utilities and PerfectWorld right there, and Run Program. Okay, and this is what it is. So next, we're going to import the worldgen file in that directory. I think that's open map set. No, we have to open worldgen file. Okay, worldgen, open that, and it will give you defaults for everything. That stuff we're going to have to all modify. Okay, so I think that's now in. We want to adjust the name to create a new worldgen entry, and then we'll hit enter. So what we're going to do for us is I originally thought this is the northeast, but it's kind of more centered because it's got the parts of the Great Lakes. So we'll just call this Mid-Atlantic. Just rename it. I think it's also good to not have any spaces in there. And then we need to adjust the map X and the map Y to those dimensions. This is where it becomes important right here. We're already there. We're going to use PerfectWorld for all the boxes here. If you want to have Dwarf Fortress just go to town on your rainfall map, I mean, that's fine. But we know enough about this region to be able to make maps for all of it. And it's fun that way. So I'm going to require that we use PerfectWorld for everything. Next we're going to do the elevation map. Now this is where things are going to start getting fun. And we're going to import from bitmap. And this is where we find our grayscale map that we've just made. So this is what all of this that we've done actually comes down to. I thought I saved that off. I actually forgot to hit the save button. That was it. Okay. So it's DF, and there we go. So that is our actual elevation map there. So now, next step is adjust the percent below sea level that's on the map, and then the percent that's above the tree line. So the minimum is 90%. If you do anything below 90%, you could get a world rejection. That's hard to believe. 90%? Is that true? Yeah, below 90. Oh, below 90% can cause world rejection. So, in other words, if too much of your land is above the tree line. Okay, so let's just start adjusting this. Wow, that looks like that looks pretty good. Oh, definitely not that high. Definitely not that low. It's good, right about there, 7%. Okay, percent below the tree line. Well, unfortunately, as things should stand, the Appalachian Mountains are not tall enough anywhere except the what's it called? They're not tall enough anywhere except in Mount Washington in New Hampshire for the tree line. So as a result, if we look at a image of the Appalachian Mountains, you really won't see any tree line. You'll see balding, but there's no true tree line. I mean, all of these mountains are right here, our highest mountains, and there's not much to see. If I look at some of the tallest peaks, you'll see a little bit of balding here, but there are none. So let's just adjust it to a value that makes us happy. We definitely don't want to use 100 because, yeah, I actually don't want to go anything above 99. But 100 that technically is what the Appalachian Mountains look like today. There's balding, but no tree line. So we're gonna head it to 99. That's the closest that we can come without causing a world rejection. Okay, so let's go to rainfall rainfall map. So for this, I'm going to go to another site that I like to use. And we're going to get a wind reference. You only get one. So we need to take a look and say, okay, where in this world do we want the wind coming from? And I guess that depends on where you plan to play most of your games. But luckily, this region has a general singular wind direction. If we go back to earth.nullschool.net and turn the wind direction on, it's not showing it today, unfortunately. We're kind of having reverse flow in this region. But the flow generally tends to be east to west as a westerly. So technically any region could work. The closest cities, I think, to the center of the region, if we want to base it on that. I'm trying to make it good for the sake of our dwarves. The good area in the center of the region would either be, let's find Pittsburgh. Pittsburgh is going to be, right about here probably. So Pittsburgh is close. Washington's a little bit further. Let's use Cumberland. I think Cumberland is probably close enough. Yeah, that's pretty close to the center. In fact, I think we know what the center is anyway. It's should be somewhere around here. 39,775 and 83.37. Wait, no, that's the edge. I didn't calculate a central longitude, but it's probably about 79 by 39,775. Oh, perfect. Okay, I take it back. Here it is. 39.65, so it's about 0.12 off, and about 79. So yeah, that's pretty close to the exact center. Okay, so let's go with that. Now we've searched it, and we want to find the most common wind direction, and we're going to use the opposite as the 2. Okay, I'm not sure I understand that, but we're going to go to rainfall map. Oh, I see. Yeah, because usually they say the wind is out of, and this is reversed. Okay, so let's see. We have to scroll down to the wind section somewhere around here. Oh, man. What an ugly place. Well, at least it's not miserable. Ah, wind direction. Yep, prevailing western wind. It should tell me what the greatest amount of wind is, but if we average this out,
It looks like the average is right about 45%. So that's west. It doesn't exactly say what the most common wind direction is, but it's west. And for the greatest rainfall shadow effect, for the fun of it, we're going to say that it directly opposes the Appalachian Mountains, which run about 30 degrees north. So we're going to say that you're down to about 120 or so. Okay. So we've now done that, and we're going to generate a rain shadow map. Generate rain shadow map. Okay. And what we get looks pretty good. I'm pretty happy with that. Being in the eastern United States, this is a very wet area, and the Appalachian Mountains are not really tall enough to make a rain shadow effect. Okay. Now if I zoom in on this region, what you'll find is there is a little bit of a rain shadow here, and the wetter areas are closer to the coast. There's not really any sort of deserts. There is a little bit of a wet area where rain will fall more. And if I look down here, let's see what this is. This is the rainfall map, but we can look at the rain shadow map, and now you'll see that it's actually heavier here. So what we need to do now is go back to the instructions, and we want to play around with the gradient and noise controls until it's realistic. Well, because this is random, I don't want to change anything. It already looks realistic. If you don't like what you get, you can alter the feature size or whatever, but this is I mean, this is really good. The only difference is there's like a little bit of a lake shadow effect up in this region, and it's going to be a little bit more wet. What that's going to cause is the Potomac and the James rivers to be a little bit drier than the Susquehanna, which I really don't have a problem with. So let's go back, and we have the gradients that we want. So we're going to adjust the percentage below desert, and I think for the U.S., this region really doesn't have any desert. So we could adjust that if we wanted to, and that's where the deserts would sort of appear, but there really aren't any. So we're going to actually set it to 0. The next thing that we're going to do is we're going to play around with the forested land. Now, if you set it below the desert threshold, then you'll start losing your desert. So if I set this to 7, and now I set that down, there goes your desert. So I think we had this set to like 16, and that was at 0. Yeah, that looks about right. Okay. Let's go to another website that I like called solargist.imaps. Now this is good to look at like the freeware stuff, but don't go for their payware stuff. It's a total ripoff. You can find this stuff free on the internet. Like if you do purchase it, it's going to tell you like you need $63,000 to calculate the average solar flux in like some random part, which is absolutely ridiculous. And what we're going to do is we're going to do landscape now, and we're going to zoom all the way in, and we want to turn all the labels and legend off. So what I'm going to do is I'm going to use croplands to simulate grasslands here. And if we do a total capture of the region, let's see, we're going out to about 40, not quite 43 because we cut it off, and 83.48, which is right about there. If we take the region as it stands now, and our southern corner is right about here, I'd say less than 10% for grassland. It's really low. Yeah, probably 9. Okay.
the percent below the forest for the amount of rainforest. So this looks a little bit high. Actually a bit low. That looks pretty good. You see how these areas down to the southeast here of our region that we chose tends to be on the green or blue side, whereas this is kind of more like a solid green. That's what we're getting at for our rainfall map here. So most of this is going to be forests, but right now we're at the 98 percentile. I think 96 is probably definitely too low. Yeah, probably right about 98 or so. Let's see if I don't think the actually, you know what? I think we do have the ability to look at it from here. If I go to image and now I zoom in here, you'll see some of these regions like here and here. These are the areas that I'm talking about, and here. These are same thing here. This area, this area here, this area, and that's a great swamp. So right there, these areas here tend to be a little bit more moist and swampy. So I think, yeah, I'm pretty happy with that. If I tick it up to 97, then let's go back to 97. Then basically the entire Delmarva Peninsula turns into a swamp, along with this entire peninsula and that one. So that kind of looks a little bit incorrect. So we're going to go with 98 as our threshold of choice. Okay, so I'm pretty happy with that. Now we're going to go to a temperature map. So you need to select a gradient type now. We're going to go to Dwarf Fortress again. Temperature map. First of all, let me just make sure that we're done with everything here. Yeah, that's just the noise field and whatnot. I did generate a rain shadow map, but I guess I could generate a noise field if I wanted to, and that would change things up just a bit. But I really don't see any reason to do that. I'm plenty happy with things as they are. I mean, the fact that they're going up the middle actually matches the creeks, so I kind of like that. So let's go to temperature map, and now we can choose, you can either have a linear map or you can have a radial map. So linear basically would be if you have a latitude, longitude, and like I said earlier, if you decided to do a polar region, you would do radial, and then you would have a pole of cold. If you decided to do an eyeball planet, like for example, if you wanted to make something of a super Earth that faces the same side of its star, well then you could do radial, and then it would be super warm on one side and super cold on the other. Okay, so for now, let's see if I can, yeah, I can bolster the zoom up a little bit. And what we're going to do is we're going to start setting percentages here, I think. Well, let me follow the rolls here. I'll go back to my rolls. So we can go to SolarGIS iMaps again, and it has a second use for us in that we can display climate across land. Alright, let's open the SolarGIS again, and we'll take a look at the area, but this time, instead of doing landscape, oh wow, it is actually showing up there. These regions that I said were heavily forested. And we're going to go to temperature instead.
And now what this is going to do is it's going to show us our region's temperatures. And there's no easy way to do this, so I'm just going to have to go out to... I'll put the upper corner at here about 83 point, right about there. And our upper quadrant would be somewhere around here, just below 43. That's not far enough. Okay, that's better. And we have a cutoff at 75, 36.55. So it's going to look right like that. Everything between this corner and this corner. I'm going to do Fahrenheit because I'm more familiar with Fahrenheit when it comes to climate. That's not anything on Celsius, but for making a more accurate map, I need it on Fahrenheit. Okay, so now generate temperature gradient map. Okay, so now what that's doing is that's giving us a slope, and that shows the gradient. That looks pretty close. So what we're going to do is we're going to try and match the slope of the lines to the slope of the real ones. I think there's a way too where you can reflect it. Oh yeah, it is actually reflected. You notice that there is a center point. So for example, if I place the center point here, now there's a hot and a cold region. But I'm pretty sure the actual hottest location is going to be most likely the Gulf Stream. So that's going to be our lower left quadrant. So let's place that right about here. That's the warmest location there. And now we're going to go for the gradients. So I'm going to put one more gradient on here to try and get a good indication of where that is. And now we're just going to go back here, and it looks like they're pretty darn close to about 45 degrees. Although in the north, they're a little bit more north-south. So let's go for about 50 to 55 degrees for the slope here. I think that's actually where we are now. So we really don't even have to adjust this much. You know, maybe 67 would be better. Yeah, I think 67 is a little more realistic here. Okay. If you want a biased temperature lean, use the gradient slope tool until you get what you need. Yes, which is what we need. You know, normally, if you go out to somewhere like that's away from the coast, way out here, you really don't have a slope. It's just kind of a function of your latitude. When you start getting close to the coast, then it starts to manipulate the climates. So let's take a look here. The next thing we need to do is adjust the percent below the cold to declare it tundra. There's no tundra in the contiguous United States. So this color, freezing, will not exist. That's gone. Next, we're going to adjust the percent below the temperate to decide what's going to thaw in the summer. So let's see if there's anything here that we get down to 44 for the yearly average. That's the lowest. Or is it? No, it's not. Let's see, a little bit further. Right around 44 Fahrenheit, 45 Fahrenheit. That's the lowest we're going to get. So, as far as I'm concerned, there might be little bits of pockets and whatnot that are lower than that. If I go back to WeatherSpark and we pick a different location, city that's really close to the top of our map would be Cooperstown.
Cooperstown, something like, yeah, Cooperstown. And this will give us the percentages of certain bands. The freezing line is right here, and at the greatest definition, we were frozen anytime between the end of March and the midpoint of November. That's only 4 months, and cold is technically to thaw. So the percent below the temperature threshold is really only 1. It's going to be like mountaintops and stuff. Okay, so next we need to go for the warm threshold. And the warm is basically what's going to freeze in the winter for any extended period of time. So let's go back here. Actually, let's go to Solar GIS and take a look at our warmest spot now. That's going to be about 60 degrees Fahrenheit and 43 in the winter. So a good way to look at this would be probably measurable snowfall. Let's take a look at Norfolk and see if they have any real reasonable snowfall. There is no real freezing time, which is a good indication that this is a warm zone. There are no exact limits here, but yeah, if I go up to freezing, there's basically nothing. There's basically nothing appearing in the freezing lines. Let's see if they get any snow. Oh, hang on a second. That's weird. Now we are displaying freezing. That is strange. The rule of the warm area is that it will prevent freezing. Any water source can be used during the whole year. Very rarely, especially when close to the edge of a temperate biome, one can have an extremely brief period of water freezing. Okay, so that's it. So we basically need freezing, I guess, greater than 50%. Basically, I want to see if I can find any frozen water around here. Okay, so this is a good indicator of where the line is. You look right here as we start moving northwards. You'll see right about in here. There's kind of a transition. Below here, there's basically no ice. Above this location, there is ice. And if we move westward, you can see that kind of shifts with the area. So we're gonna try and adjust that a little bit. So below warm, we'll say, getting close. Oop, too far. Let's see where the ice was. I'd say right about there. That's probably the temperate warm boundary. Okay. Next is the percent below hot to declare everything that will have water year round. So in Dwarf Fortress, there's this thing that doesn't exist on the Earth called scorching. Wait a minute. Are we there yet? Oh, okay. Yeah, water year round. So during the summer, if you're in the hot zone, which is on there for display, it is so warm that you'll have places drying up in the summer. So we're not going to have that. Now there's this other thing called scorching, and that is an area that is so hot. This doesn't exist on the Earth nowadays. It would have during the Cretaceous. This is like regular yearly temperature averages around like 100 to 120 degrees. We don't have anywhere on the Earth that behaves that way. Even if I go back to the iMaps and go to the hottest regions of Earth, let's see where that would be. Probably right about here in Western Africa. The yearly average is still only about 86, and the July average is like 83. in the Mesozoic, you could have water temperatures up to like 135 degrees Fahrenheit or 60 degrees Celsius. It was ridiculous. So we don't have that kind of situation here. So that's what we're going to end up with. That's our temperature gradient map. So now what I want to do is try and mix it up some. So we're going to generate a noise field and adjust until we get something that kind of looks like the map on SolarGIS. I think this is probably as close as we're going to get. The neat thing about what we have here is... what the heck? Won't let me look at the top of the map. Okay. So what I notice here is we have a patch of warmth around the area where Washington, D.C. is, which is also advantageous. We also have another warm patch kind of up where like Philadelphia is, which is another advantage as well. Most of the lower areas here, the river valleys, tend to be a bit warmer, and we even have a little few splotches up here in the northwest for cold. So I kind of like this map a lot. So I think we should be able to move along with this to another step. Okay, next we need a drainage map. So this is to kind of determine what the terrain looks like. So the first step is to generate a standard deviation map. So go ahead, generate. All right. So now we got various drainage regions. As you can see, it pretty much identified Lake Erie right away. This cutout here is Lake Erie. So let's take a look now and see. The next step is to adjust the map weight slider. That's this one. I see. So you can control everything from hills to dune or swamp. I don't have any real reason to say anything other than 100%. So I'm going to keep it there. So on a natural map, it seems best to leave the noise field alone. I mean, you can play around with it, but I really don't have any use for it. As you can see, this is kind of already relatively realistic. Okay. So now we need to decide the dune and swamp areas. So I'm going to adjust this until it looks right. So if we start off, you'll see actually the Dismal Swamp and the eastern Chesapeake Bay are identified. We don't really want to get much more than these areas here. It's definitely not regions, so I would say certainly no higher than 7%. But there are some swampy areas down here that we should probably try and cover. Probably 4% is a good... yeah, we definitely want to get the Delaware Bay. 4% is probably about where it needs to be. Next, you're going to adjust the rocky grass threshold to control the amount of land that will actually kind of sink into the ground and become groundwater.
So right now we're at 85%, and we can manipulate that a bit until we get something that's a little more realistic. It's probably halfway in between 60 and 90. So let's try 75 for a good compromise. Yeah, that looks pretty good. It would be nicer too if we could get some valleys in here, but I guess 75 works just fine. Okay. And now we're going to adjust the amount that doesn't drain by running down the mountainside, which is the hills threshold here. We definitely want to leave valleys with this one. So we'll try and right there, I think, is where we want. We don't want the valleys connecting. I think that would probably be about where it should be, right about 94%. Okay. Next we're going to do volcanism, and I think volcanism is something that's required. So we have to generate a elevation cusp mask, or we're going to get a rejection. Okay. So that is going to tell us where the volcanoes could lie, if there were any. And not surprisingly, they're all in the Appalachian Mountains. And we can change a lower and a higher volcano region. So for example, we can say above a certain place, you're guaranteed to have volcanoes. Below a certain point, you're guaranteed to not have them. Okay, so now we're going to decide a few things now. I've got land that works pretty well. It's pretty noisy. So we're going to determine now the amount of land that's considered volcanically extinct. So if we do 100% below zero volcanism, then we don't have any volcanism whatsoever. So we're going to kind of limit that to, actually, you know what? Here's a perfect area. This is a really good way of determining your volcanism. So there's going to be a spot here and a spot there. That's pretty much it. I'd call it right about there. The next thing is the volcanic lavas region. So this is the area that tends to get flooded a lot of times with volcanic rock. So you probably want to adjust that again so that you get your valleys filled, but it's not encompassing the entire mountain range. Pretty much when the valleys connect, I'd say right about there, 72, 73, or 87, 88. That's probably where we want to be. And then next we have the volcano threshold. So anything above the volcano threshold will start to spawn volcanoes at the mountain peaks. You probably want that relatively low. Again, unrealistic, but I'm pretty sure that you can actually get world rejection at Dwarf Fortress. It's just one of the things that have to really exist in a world are volcanoes. So I think 96 is probably a good value there. Now this is fun. We're going to do a savagery map. So we get some options here. Right now this is 100% evil. So we can do Savage East,
let me lower a few things beforehand so that you can see what's going on. A lot of people like to do Heart of Savagery. That basically means that the really nasty areas are in a particular region. There is Savage East, which means the East is bad, and then there's Wild West, which means the West is bad. And then there's Surrounded, which is basically you have a good region and your surroundings are evil. And, you know, you can generate a noise field and everything else. So, I guess we have to decide where we want it. It's too bad you can't do north and south, because I kind of like the idea of Savage North. I guess it's really up to what you want. Because this is the United States, I guess we're going to go with Wild West. We don't have a center point, generated savagery map. Let's generate a new noise field. Always good to be somewhat realistic there. And let's mess around with the sliders. So the first one, the benign threshold, is the amount of map that's considered jolly. So let's draw that until it's out of the Appalachian Mountains. Probably right about there. And then the neutral threshold is everything that's evil. So let's consider that everything on the other side of the mountains. So let's go back to elevation map here. So it's basically going to be this region up here, about halfway into the map to nothing here. Let's see if we can, let's put the weight back at 32, but we'll draw down the feature size, see if we can get something that we like here. That looks pretty good. That looks pretty realistic. I like that. Okay. Alright, so now is fun. We get to actually preview what this thing looks like. We go to biome map. It's going to generate a sample world for us, and this is exactly what it's going to look like. Let's try and zoom out so we can see the whole thing. And this is what the world's going to look like when it generates. You can get temperatures on here. The highest temperature we can get on here is about 69. The lowest temperature that I can find is about 9. So a little bit swingy, but fairly decent. I don't think there's any way to create lakes, unfortunately, in Dwarf Fortress. My hope is that it will just pocket this area with lots of lakes. The Lake Erie thing is more of a Minecraft thing, but this is this should be a pretty closed basin. So I'm hoping we're going to get some lakes in here. You'll see some elevation in here. Somewhere in here it'll tell you what the different biomes are, but if we zoom all the way in again, we can take a look around. And you might not know what this material is, but I can basically tell you. So all these reeds, these hooks and apostrophes, these are swamps. That's basically what that is. And that looks pretty good. That's about what we set. That's what we set it up to be. Now, as for these arrows, these arrows you see, those are pine forests. So for whatever reason, Dwarf Fortress likes pine forests in this area. The bright green areas are savannas. So the T's and apostrophes here that are bright green are savannas. These bright green ends are rolling hills, and these houses and triangles are mountains. So these are where the really high elevations are in here.
At some point, it'll run rivers down through here. As we go up here, okay. Now these clubs and paragraph symbols are hardwood forest. So we've got broadleaf hardwood forest like oak, pine, and oak and hickory in sort of like the evil regions here. So that's pretty much a summary of the map. I mean, it's pretty bland because it's a small region, but I'm pretty happy with the results. It looks pretty good. The next thing that we need to do is adjust some parameters to what we want them. Don't touch anything that's red. It's extremely important. So we can adjust anything we want in here that's not red. Like I can adjust caverns and stuff. That's for wiki reading. That's gonna we could last we could stay here hours and hours and hours just trying to get these things correct. So seriously, like I can't go through these. Just look it up. So yeah, that's about it. I'll show you how to export once we've finished, and I might tell you interesting parameters that I've put in here. Okay, so this is what we have. We have the surface, and then you have to go down 20 units before you hit the first cavern layer. Then you have to go down 30 units, then you hit the second. You have to go down 40, and then you hit the third. You go down 40 more, and then you've hit the magma. You go 15 more, and then you've hit the bottom of the world. So we're going to go ahead and export the worldgen file now. Go ahead and launch Dwarf Fortress now. It's the third one down. So hit arrow down twice. Design new world with advanced parameters. Okay, so what you want is to pick what you exported it as. In this case, I picked Northeast US. So that's the parameter set we want. So we want F1 to load. And enter, and it is going. Okay, a lot of stuff is happening now. Rivers are running, lakes and minerals are being deposited. Pretty exciting. It's finally jumped into action now. Continued with vegetation, evil areas, good, bad, creating terrain, setting good and bad things, and now we have the age progressing now. Alright, 2:15, I'm going to hold enter until it stops. Oh, it's not stopping. Why aren't you stopping? Oh, okay. It's finally stopped. 2:18. Okay, so where are we? We're in the northwest corner. Oh, what's this? Frost. What is this? It must have not used the, yeah, I guess it didn't use the worldgen file I gave it. It shouldn't have frosted over there. But whatever, it's not much of a problem. Okay, so let's see what the east looks like. Not bad. Strangely uninhabited for as jolly as it was supposed to be. I think we just told it to use the elevation, but nothing else really. Okay, so it looks like North America, for some reason, is called the continents of clinching. The Atlantic Ocean is called the Ocean of Glitter, which is pretty funny. And apparently it thinks the Chesapeake Bay is part of that. So now you get to tell your friends why the Atlantic Ocean is called the Ocean of Glitter. Let's see what the Susquehanna is called. Apparently it's called the Creative Long Jungle River. Interesting. Oh no, the Creative Long Jungle is the name of the forest. I'm seeing the ace spike a lot. I wonder if that's the actual name of the appellations that we got. Sizzling Crest. We might have different names for this thing. So the Central Plains, it looks like it's called the Faded Forests. The Southern Appalachians are called the Intricate Hills. Everything else is pretty much the Creative Long Jungle. Except for the Delmarva Peninsula. That's apparently the Royal Merc, which is pretty funny. Okay, so I pretty much can't go on, so our only choice is to press U to use the world as it exists. And it's going to finalize a few things now. And lo and behold, Xesor's Lozgo, the ever-seeing universe, has been created. Which is pretty funny, because the NSA is going to be like about there. Right around here is where the NSA is. So that's actually kind of funny. So this thing here is really bad. It's called a necromancer tower. The Dark Goblin Fortress of Atzbu, apparently. And there's the Atlantic beaches have the Goblin Fortress of Song Spezlu. Interesting. I want to try and create an embark profile so that we can exactly see where the Susquehanna goes, because it'll follow these names as you go northwards. Now, there's so much of a cutoff on the north side that you really can't tell where the river actually begins. But it looks like instead of following the modern day Potomac River, it's going out this way. It's a really long river, and it's a really fake course. And it really surprises me that, for whatever reason, Dwarf Fortress did not choose to use any of these rivers except for the Potomac. It comes on here, and it begins somewhere in these mountains. So, yeah, I don't know. I'm kind of not impressed. I think we may have exceeded the size. If we lowered the size a little bit more to only the Chesapeake Bay, I think we would have been okay. But we're just reducing it so much. There's a big problem. So the Great Dismal Swamp is called the Embraced Merc, which is pretty funny, and it's also kind of cool how it did successfully predict a swamp here. So yeah, that's about it. There's an Elven Forest Retreat up near Reading. Bunch of Elven Forest Retreats in the valley there. That valley has a special name to it. I forget what it is.
I think this is about where Pittsburgh is here. And there's lots of elven retreats there. Let's see if there's any mountain homes or fortresses. Oh yeah, the Dwarven Fortress of Daeslavs. That's nice. So there are a few Dwarven fortresses here. Ipet-Hinen, Avalcog, Astkasoth. Yeah, there's a lot of them here. That's good. Dwarves are doing good. So we got lots of dwarves and lots of elves. I think there's a few, yeah, goblin places. This is the Dark Goblin Pits of Gostazolak. Let's see if there's any humans around. I know we saw that human hamlet, but that could have gotten wiped out. This is probably all... Yeah, that's just abandoned hills there. Ugly plain. Doesn't do any good. Well, that's pretty funny. It looks like the humans didn't fare very well. I forget exactly what you look for those, but I don't see very many. Very interesting. Okay. Alright, I don't want to waste any more time, so we'll go ahead and stop here for Dwarf Fortress, and I think we're going to pick up how to continue with Minecraft. Okay, before we go, I couldn't help but take a look at the embark screen just to see what we've got. So this will tell you a few things about the region. On the left, we've got a local most map. In the middle, we've got a region map, and on the right, we've got a world map. So if I go all the way out to the Atlantic Ocean, that's definitely the Ocean of Glitter. And it thinks that the Chesapeake Bay is also an ocean, and it's calling it the Ocean of Glitter as well. Let's see if there's anything that we haven't seen yet. Oh yeah, the Susquehanna River's name is well, it's cut off. Guess we'll never know what it was called. So that THDFNSW or something should tell me where it's going. Del Ring, that's another river. Okay. So following it up here, see where this thing goes. Okay, it decided to go west. That's different than what we have today. Okay, still going this way. Still trying to find the source of this river. Let's just, see where it goes. I'll do this off camera. Okay, so good news. We've reached a point where it's smaller, and now the entire name is visible. The Defensive Swamp. That's the name of the Susquehanna. Just continue following this thing up. Okay, you ready for this? This is going to be pretty funky. So, it begins in the cheerful forests in the Vermilion Hills, which honestly is a really nice name, but here's what it does, okay? It begins at this X, and it does a giant corkscrew. It goes down here for the Grand Tour, goes up. So it basically swings all the way around here and unwinds, corkscrews up to the top of the watershed, and then comes back down. Pretty crazy. Let's see what the Potomac is called. No idea. It would be nice if so many names didn't get cut off. Probably the Cluster of Fight or something like that. So the whole thing is basically called the Ace Spike. So they have different names of what the mountains are, but yeah, it's basically the Ace Spike is the equivalent name. Let's see what the Appalachian rivers are called.
Oh, I could have guessed. Cut off again. I don't even know. Let's see. I think we're in the Pittsburgh area now. Bleached clear. Well, fantastic. This one flows down onto the into. I guess the reason this is here is probably Lake Erie. This is like the frozen, although not all of Lake Erie, which is kind of dumb. Yeah, this should not be tundra. I don't think I set that up right when I did. Okay, I think we're done here. Okay, so going back to Minecraft, remember we had saved off a larger, well, technically it was the original file, and then we saved off a lower resolution file, and we saved that one for Dwarf Fortress. So in Minecraft, you want to pick the biggest file that you can possibly have. So the ideal situation is the native resolution of whatever your grayscale height map was. So now what we're going to do is we're going to use a very powerful Minecraft tool to essentially translate this map. So what you want to do is you want to download WorldPainter, and obviously you're going to need Minecraft for you to be able to play in this world. Otherwise, it's just going to generate a Minecraft save file that you won't be able to do anything with. So you go ahead and download whatever version you want. It updates fairly often, but it doesn't update as often as Windows does. I have version 2.55. I think right now it's at 2.57 or something. Generally, you want to keep it relatively well up to date if you want to be able to have versatility across all the Minecraft modes. But I highly recommend using the Anvil format, because if you use the older format, two things can happen. One, world overwriting when the seed updates, and two, you can also have limitations to height to only 128 meters. Now, in some cases that's good, other cases it's bad. So anyways, you download it, you open it up, and it looks like this. So these are just some tool tips here. Basically what you do is you select something to draw with, and then you select a brush size that you want, and then you paint. So if I wanted to create my own world, essentially, I could use these tools, but it would be quite difficult to do. Like, let's just give an example, right? Trying to make something like North America. You're going to be in here for quite a long time trying to build stuff, so it's not going to work very well time-wise. And even when you think you have it, it's still going to be off. So I highly recommend just going with that's supposed to be high mountains. There we go. So I just highly recommend, instead of going about this business, you just use real life. So what we're going to do is we're going to hit File, Import New World, and now we're going to go to from height map. Oh, but wait a minute, I forgot about that. Before we do this, we need to go back to our saved file, and let's find it real quick. So you get your final map is a bitmap. So what you want to do next is open this in just regular old Microsoft Paint and do Save As, and you want to do PNG. That's it. That's all you got to do. So what you do is you convert it to a PNG, and that PNG will allow you to import. Don't do JPEG, because JPEG will reduce your image. So this Northeastern US Final MC2 is our file. Okay, so we're ready to import now. So we'll just go to File and Import New World from Height Map. You don't need to save this world. Okay, here it is.
So we want to confirm a couple things. First of all, the image size, 1061 by 1036. And we can confirm, yes, that is the size of the image. Lowest value is 5, highest value is 245. So let's go ahead and open it up again and just confirm that that is correct. So we'll just open paint.net and take a look here. Okay, so it's up. Just go to levels, here it is, and just confirm the histogram here. There's a way somewhere to control what you see. So it looks like the highest is actually 253. So what we'll have to do in this case, if you get something like that, what you will need to do is upscale this image. So it'll say the highest value is 245, and then what we'll have to do is we'll have to say image 245 equals Minecraft 255. That's for full scale. Now, at the scale we're going to do it, we actually want to jump the scale down, because if you import it the way it is now, it will be highly unrealistic. You will get cliffs that are beyond even the Swiss Alps. So, in order to make this be somewhat realistic, and when I say somewhat realistic, I mean mountains that you would draw on a map, like 45 degrees, not like 80 degrees. So what you're going to do now is you're going to want to scale your world. The most important number here to pick is scaled size. This determines how long it's going to take to generate the world. I have a really old computer that's doing this recording, so if I go anything above 3 by 3 kilometers, so 9 square kilometers, I'm going to be sitting there basically the whole night. If I go up above 4 by 4, I probably will never finish because the computer will just run out of memory. So 3,000 is my limit, so I'm going to set the scale to about 290%, and that puts me right at my 3,000 limit. I want to make it as big as I can, but you'll also get a little bit of differences. Don't change the height unless you have rendering problems on your computer, i.e. it's even worse than this one, in which case you might want to go down to 128, but I'm not going to. So the next thing we need to do is talk about exactly how we're going to scale this properly. So what we're going to do first is match our values. So the highest value of the image is 245. We're going to match that to 255. So now the next thing I'm going to do is I'm going to set the bottom of the image to a different Minecraft value. And I'm going to set the top as well. So basically what I'm going to do now is define where I want the bottom of the world and where I want the top of the world. I highly like the 64 meters underneath the surface. So what we're going to do is we're going to set the bottom of the world, so in other words the lowest part of the map, to about 60. That'll put the quarries really low, and that's the way you want it there. So the next thing that we should probably do is limit the height. I'm going to open it with 255 and see how it looks with that reduction. The next thing we need to do is choose our water level. Remember I said 11 is the first wet pixel. So what you're going to do is you're going to raise this water level until this image value is 11. And that will tell you exactly where, right there, 69. That is the level of the water in this world. If you get this wrong, and that's 10, you're going to have dry spots that aren't supposed to be dry. It could be realistic in the case of Lake Erie in the Chesapeake Bay. If you lowered this down to about 4 or 3, that would give you about what was around about 10 to 15,000 years ago. Likewise, if you set it up to about 16 or 17, that'll bring you up 100 or 200 feet, and you'll be in uncharted territory, or sort of where the Paleogene was. Not quite as high as the Mesozoic seas, but pretty high. We're just going to go with good old 11 there. You have the option to create a void below the image value of a certain point, so you could essentially have the world bottomless. So if we set the void to 11, instead of getting water, you get gravitational space. So that's obviously unrealistic for the Earth. The next thing we're going to do is we're going to start controlling the theme. This is going to tell the map what to make where. So what we're going to do is we're going to put down a few layers here. So this area of the world happens to be quite... this is the surface. This data only affects the surface. It tends to be quite sandy, so we're going to go ahead with sand as the terrain type. And that will basically say if it's under the water level, then make sand. Actually, you know what? Because it's going to override with beaches, 2 levels below the water to 2 above, that's going to add sand for us, in which case we want clay. Clay is more realistic for deeper down. So there we go, clay. So anything below sea level will be clay. So now the next thing we want to do is we want to add a layer, and we're going to say grass. And the grass can be anything above 69. So anything above level 69 will appear as grass. Good. The next thing we want to do is probably add bare dirt. That's the next thing that you have. Now this region doesn't get high enough. The highest elevation in our map is only about 5,700 feet, and that's not high enough for a timberline. What you do see is balding, and let me show you what that looks like in a minute. Okay, so one of the highest regions that we're going to have in our map is the Dolly Sods Wilderness. This place is crazy. It's not above timberline, but there's crazy stuff that you don't see anywhere else. Like you see eastern fir, you see other sort of stuff that you only see in Canada and in the Arctic. It's really crazy. Like for example, here's stunted trees, barrens. There's some really, really crazy stuff up there. So that is, here you go. So this is kind of what we're going to get in the highest regions. That's probably a southward view. And here's kind of a, image of the more barren landscapes. So not quite above timberline, but getting close. Here's a good example. So that's some exposed rock there. We'll put some exposed rock in at the summits because that's kind of normal. Here's another good view. So basically, it's kind of grass, but we'll put a little bit there. That's right around the limitation here. So what we're going to do is we're going to say, well, the highest we set was 255. So 255 corresponds with just about the world limit, 5,700 feet. Okay, so remember what we did earlier. We limited the bottom of the world to be about 60, and we limited the top of the world to be about, what did we set it to? Set it to 255. So this region altogether represents 5,700 feet. So then what we're going to do is we're going to figure out exactly how high we want to make it. So if I multiply here by 5,700 and then add 64, add 60 because that's where the world begins. There we go. We get a good number. And instead of this, I'm going to add a number here. And perfect. So Dolly Sods is about 4,000 feet elevation, so we'll decide that's the point where it's going to be bare dirt, and that corresponds with 197 meters. So we're going to say dirt at 197, and I think it needs to be perma-dirt, because dirt will just grow grass. Okay. So that's the next level. The highest level, we're not going to have a snow level, so the highest level is going to be rock, which is a mix of cobblestone and some stone and mossy cobblestone. So that's rock. And we're going to say only make rock at the highest summit, so that's 5,000. So we'll set this to 231. Okay. I keep going back between feet and meters, but with elevation, I'm more keen on feet. But there's some other crazy stuff, like on speed, I'm more keen in meters per second. It's very strange. Okay. Let's see. And then we have a frost layer that we can choose what to do with. Let's see if we can add anything here. Now that's pretty handy. So we can add certain layers here. Okay. So what we're going to do now is we're going to configure where the frost layer is, and this is area that's snow all the time, and there's pretty much nowhere in the Appalachian Mountains that frosts all the time. But if I don't add this in, we won't have any snow. So for the sake of actually having snow, what I'm going to do is I'm going to set this up to about halfway between rock and permadirt. So I'll put it at 215. That way we have some snow in the world, as opposed to it being completely snowless. The next thing I'm going to do is I'm going to add start adding the forests. So let's see what we have here. What we'll do is we'll add some pine forest, and we're going to start at the balding layer, which is about 4,000. And I don't remember what that was now. Okay, so the balding level is about 197. So what we're going to do is we're going to add from, now we need a lower level. We'll say from just about 200 down to there's a transition between an oak forest and a fir forest around 3,000 feet. So this is right here is low enough image where you still get deciduous, and further up you'll get carnivorous stuff like this. So we'll say about 3,000 feet. And that'll give us 162. So we'll say everything between 162 and 200. Whoops. I have to add another layer. From 162 to 200, we're going to add pine forest. It's just everywhere. So I think if we do feather, what that means is when you get close to the limit, it's going to cut down on the amount of those kinds of trees there. So I've added a pine forest. The next thing I'm going to do is I'm going to add a deciduous forest, and we're going to say that that's going to start around. I don't want it to be too low because I want to be able to simulate croplands, and it's just a pain to tear the trees down. So we'll just say 94, which is 1,000 feet in elevation, all the way up to pretty much the transition line plus a little bit because we're doing feather. So I'm going to say about 210 give us a deciduous forest. There we go. Okay, I think that's it. So let's just check everything again. Scaling looks good. Everything looks good. Okay, so this is it. This is where our world actually gets not created, but it's where it gets rendered. So let's go ahead and see what it does. Okay, so we've got it. If I turn off the contour rings, it'll be a little bit easier to see what's going on here. So this is an auto biome forest, which means this area that I'm looking at here is above 1,000 feet in elevation. Let's see if we can find, here's some really high areas, and here's some permadirt. We're still forest. Get a little bit of ice plains now because the altitude is getting quite high. I'm looking for I guess it's forest even when it's pine. Anyway, the real test is going to be looking at the Chesapeake Bay. And you know what? That looks pretty darn realistic, I must say. That looks really good if you compare it with real life. I'm pretty happy with that. Let's take a look at the world on a grand scale. And that's what we've done. If we turn off the biomes, we should be able to see a little bit better here. So yeah, everything looks good except for one thing, and that's Lake Erie. So the issue is Lake Erie is above sea level. Now, unlike Dwarf Fortress, which could not handle that issue, we can actually tell Lake Erie that we want it to exist. So what we need to do is we need to zoom in and we need to find the Niagara River. And the Niagara River will tell us exactly where to add the lake. And that's right here, this little stem right here. What you do is you click this blue area called flood. Very carefully click in this region here of the Niagara River. And it fills the entire Lake Erie. Done. Just like that, we've got Lake Erie. Okay, so I like what I'm seeing on some of these areas here. Let's see, the Dolly Sods region is, let's see if we can get a latitude and longitude on this. Yes. It's at 39 and 79. So 39 is going to be somewhere in the middle here. 79 slightly further west. So let's see, somewhere in the middle area. Right about here is probably, it's isolated from the rest of the high mountains. So this area right here is probably Dolly Sods. And just as expected, that's kind of permadirt. So that's what we wanted to see. Lake Erie looks perfect. I just want to go here and look at a few other things. One thing, yes, this is a problem here. We're going to need to lower the terrain here by another meter because, well, for some reason there's an issue. I also forgot to tell, or to note rather, that, let's see where it is. Oh yeah, I complained last time that Otsego Lake got off, and that really, really irritated me. So much so that I actually decided to include it off camera. So here it is. This little corner up in here, you can't see my cursor because it's black. But this corner contains Otsego Lake. So now we have the entire Susquehanna River Valley. Going back down here,
what we're going to do is we're going to fix a coastline. So what we're going to do is we're going to do this one layer at a time. We have this region here which should be 2 meters deep in order to be realistic. So the height is 69, that's 68. So what we're going to do is we're going to say at or below 68, lower by 1 to 67. So what I'm going to do is I'm going to choose a constant circle. I'm going to choose raise or lower the terrain, and I'm going to click once, and now we've got height 60, 67, perfect. And now what I'm going to do is I'm going to click flat and click in the middle here. So now what I've just done is I've made this entire region 2 meters deep. The next thing that I'm going to do is I'm going to go out here where this says 68, and I'm going to pick only on. Sometimes it'll autosave. That's a good thing, and sometimes it's a bad thing if you have things selected. Okay, so it doesn't like that. So what we're going to do is we're going to say at or above, and the value is going to be 69. We're going to level off with the rest of the water. And if I do this right, everything should be good. The first thing I'm going to do, though, is actually save this real quick. So just click the save button to save it. So what we're going to do is we're going to click just about here. Be careful you don't overlap. The advantage of having a water-surrounded world basically means that the edge of the world, which we can't control, will also look like ocean. It'll just be a little bit further down. Alright, so let's see if this... No, that's not correct. Let's try at or above. Actually, no, we want at or below. We want at or below, and we want 69, and what we're going to do instead is lower. Because if we do plateau, it'll then raise this other area. So let's try that. Okay, that went way, way too deep. So it looks like we're going to need both at or above 69, at or below, or at or above 68, at or below 69. And that's done it. Okay, so if we do this right, that should fix this area where we've had a few problems. Okay, and what you're seeing now is you're seeing the Delaware coastline come into view. And that's the Delaware Bay, perfect. 2 meters, just as expected. Here it's less of a problem because everything around here is only 1 meter. So I'm just going to continue adding a few things here. Although I won't add the western shore or the eastern shore of the Chesapeake Bay there, because if I do, what I'm doing essentially is I'm making a 1 meter cliff, and that cliff is going to be everywhere on this part of the shore. Now that's fairly normal for this region to go up abruptly and then be completely flat after that. So it's okay that we're going to be doing this, just as long as we stay away from the inner regions there. The next thing we're going to do is also hit up the Virginia coastline here, and that looks pretty good. I also added a little bit of pot lakes there. That's alright because this area tends to have a number of swamps. Okay, and then now we need to get the New Jersey region. So we'll just do that. So the next thing we need to do, because it goes straight from 68 to 70, is we're going to have to create the Delaware River. So what we're going to do now is we're going to do lower at or above 69. So we're going to go down only 1 meter, and what we're going to have to do next is import our image overlay. So what we're going to do is we're going to zoom all the way out, and let's see. So it's going to be, there should be toggle image over, there we go. Where is this thing? Yep. You want to load the image that you just picked, the grayscale image. And you're going to scale it up to exactly the same scale that you adjusted the map to. So we're going to do 290. The next thing you're going to do is you're going to change the transparency to 0. Recognize a very easy landmark. And what we're going to do now is look at that landmark and change the transparency to 100. And just look. Oh, it doesn't like 100, so we'll do 99. Perfect. Okay. Everything looks good. So that tells us that our image is correct. So set it to something where you can still see what's going on, but not so low that you can't really see the terrain. So I'm going to set it to about 15, I think, is a good balance for the Delaware River. There we go. Okay. Let's see if there's anything else we need to do here. We don't need any offset in this case. There's no borders. Yeah, everything's fine. So we'll just click close. So we've now got a image that tells us where everything is supposed to go. So what we're going to do now is we're going to follow up the Delaware River and just confirm this only goes down 1 meter when we lower the terrain here. I'm going to disable the at or below. Okay. Yep, that's done it. So as a matter of fact, I can actually see where the river's supposed to go through right here. So I'm just going to color this area in here. Again, picking the lower and at or above 69 prevents the ground from being lowered any lower than 69, which is sea level. So I'm just going to fill this in a little bit. And that should do it. So what that's going to do now is this area here is going to be the Delaware River raised just about 1 meter. So before we do anything else, we should really check to see what the world looks like to make sure that things aren't too steep. So I'm going to go ahead and save again. And now what we're going to do is we're going to bring up something very amazing. It's a powerful tool which allows us to see what the world is going to look like when it's done. So let's go ahead and open the 3D view. So do View, Show 3D View. And this will show us what the world looks like. Okay, those are way steeper than real Appalachian mountains. Let's see what that looks like when we turn the image sideways. There's a nice cool profile of our entire region now when you do this. This isometric view. You can see basically all the way down from the ocean to the coastal plain to the Piedmont, and then you get your mountains. So that's not too bad. It's really steep, but it's not much steeper than 45 degrees. So it makes for a good like storybook area, but it's not necessarily realistic. So I'm fairly happy with that. It's okay. Let's see, what is this? Yeah, Shenandoah Valley right through here. So you're going to have to make a river that goes through here, one of the many rivers. Potomac River Gap right here. That'll flow its way. Actually, no, that's a Susquehanna River Gap. Potomac River Gap is right about here, coming through here. So we're going to have to all fill that stuff in now. It's not too big an issue, but what I do want to see is what my far viewing distance is, because you don't want to have half of your region viewed as a giant mountain on one border. It's not realistic. So let's see what far looks like. So you're not going to see the nearest mountains pretty much until you get to Washington, D.C. And if you go a little bit further, right about here is where you start to see the first mountains. So I'm pretty happy with that. As long as we're outside of the far viewing distance. Yeah, I'll call that realistic. We'll settle for that. So I like this map. We're going to keep it. So now the next thing that we have to do before we do anything else is we have to do some of the most fun and or boring parts of the entire thing. And I'm going to start with the Susquehanna River. Any river that you want to continue upstream, you're going to have to fill in manually. And this really stinks. So what I'm going to have to do now is fill in at or above the minimum altitude and go all the way up the river. And it's going to take a long time. So sea level is at 69. So what we're going to do is we're going to say at or above 70, make a water region. So what we're going to do is we're going to go to terrain, and you want water. And what we're going to do, make sure at or below 69 is selected. You don't need at or above. Pencil is what we want. At or below 69, 70. See what that, perfect. Okay. So what that's going to do now is that's going to make the Susquehanna River. So zoom all the way in, and we're going to have to say exactly where we want this to go. I recommend just using the constant circle because otherwise, it doesn't work. And you're going to get a little bit of a waterfall here, so you don't want to go too far with it. I can demonstrate basically what that looks like here. I'll have to turn an edge on, and that should give us a good view. So right here, there's going to be a little bit of a waterfall, and that's normal for the Susquehanna River. It's actually the longest river in North America that's not navigable by boat because of the amount of rapids in it. So that looks good. We're going to just continue doing that. So eventually you're going to reach a point where you're going to dry out, and then you raise it again, at or above 71. And this time, don't go much beyond there. You're going to get a waterfall at or above 72. And let's try that. Okay. Now this is actually somewhat realistic for the river to have these little ridges in them, as long as they're not like more than a meter or two. So you may choose to leave them. You may choose to keep them. It's up to you. Really, but just recognize if you go too high with this, like if I do 73, oh no, that does work. Okay, that's no problem then. I usually prefer to get rid of them if I can, because I like using boats to get around in Minecraft, and it's a lot of fun riding like 450 miles down a simulated river. So this is basically what you're going to do. You're just going to continue increasing this height value and trying to get upstream with a constant flow of water. Again, just making sure that you don't go too far with it. Like for example, this time we go from 74 up to like 80 and back down. That's just not going to work. There's been a little bit of an issue there. So what I'm going to do is I'm going to have to lower that terrain. But this gives me a fine guide of where that river bed is going to be. So like for example, some of these water gaps unfortunately don't show up properly. So for that you just have to kind of find where it's supposed to be. And again, don't go too far with it.
at some point we're going to have to decide the exact rivers that we want to include and the ones that we don't want to include. Those are only going to be the major ones, because if we include the creeks, we're going to be here forever. Alright, so this is it. It's not perfect, but this is what we have. Susquehanna River, basically, all the way up. So what I'm going to do now is I'm going to try and get rid of a few water gaps. And the way we can do that is by doing plateau, but only for a brief period of time, so it's not a magical fix. So if we zoom all the way in here, we've got a area which does not conform. So what if I do now is I'm going to grab plateau, and that should level it. Except we did at or below, which doesn't help. There we go. So now we've just cut through the mountain, which is exactly what we wanted to do. I'm going to do the same thing there. And every time I find one of these, just know that if you do this too many times, you're going to get a series of waterfalls, and it won't look realistic. So you have to know when to do it. Like, for example, it goes from 75 and then back up again. And it won't be perfect. Unfortunately, you know, there's just no way to spend just too much time to spend if you expect to get it right. Here's an area that badly needs it here. Just cut right through there. And what we're going to have to do is we're going to have to come back and then refill the lowest level with water, which is going to be real pain. So yeah, this is basically how you do water gaps, is you just have to cut through every single one of these, and it's pretty annoying, to say the least. Okay, so Susquehanna River's pretty much done. I cut through all the water gaps. We basically have a run all the way up to Scranton, so that's a good distance. I even got Otsego Lake here by flooding. And we're also going to have to flood. We have another really neat feature. We have the Finger Lakes, and we're going to have to flood those. Pretty obvious where they go. And we'll have to check and make sure that there's no other lakes around that need to be filled. Probably have a few reservoirs that we'll need to do as well. I think I can see where Loch Raven is, and that will need to be filled. Be very careful when you're painting this terrain in, because you can paint it like onto mountains, so you need to be very careful about where this water goes. Alright, so here we go. Like I said, you got to pick your rivers, and we've actually got 3 different watersheds. We've got the Atlantic watershed, we've got the Gulf of Mexico watershed, and we've got the Great Lakes watershed. So those are the rivers I'm doing. That's a total count of 25. If I did any more than that, I'd be going crazy. So next I'm going to start knocking them out one by one, starting with the largest and moving on to the next largest, and so on and so forth until we get to the smallest rivers, and then things should go by faster and faster and faster because the rivers are shorter. Okay, so the Niagara and the St. Clair are super easy. First of all, this is a lake. Next thing I want to do is see if there's any land lower than this. That's looks like 89. Getting pretty close to, yeah, that right there might be the tip of Lake Huron. Let's see if we can, no, that's too high. Okay, so we're just off of Lake Huron. It would be right about here, but we can see the valley right there. So what we're going to do is the exact same thing. I don't even need this because the land here is so flat. So what we're going to do is we're going to pencil in a river to follow this channel here. Just right like that. And when you get to a curve, it's normal for rivers to overshoot. That's what they like to do. So I recommend doing that kind of thing. Makes it a little bit more realistic when we don't have the full map on here. Okay, just like that. So that gives us the St. Clair. Oh, we'll have to get, there's one little spot between Lake St. Clair and Lake Erie that we'll need to get right there. Just do at or below 89. So we'll just do what we did on the Atlantic coast. We'll just lower everything by 1. And anything at or below 88 now, we're going to light up. Not too much though. We only want just a little bit of flow going through there. Flow's not too high. Perfect. Okay, so now we're going up to the Niagara River, which is up here. And what we're going to do is try and see if we can identify where Niagara Falls is. It looks like it, again, is going to appear off the map. Again, this area is extremely flat, so what we're going to do is we're just going to paint a nice, little river going through here. And we know it's going to go somewhere through here. Okay, so that is it. Now that I've shown that, we'll go back to the Ohio River Valley and see what that looks like. So what I did was I did a different method where I would essentially fill an area, and then when it stopped filling, go up to the next area and fill it. It worked pretty well. These are going to be some really fun rivers to explore on the western edge of the map. So we have the Ohio, and then we have the, I forget what the name of that river is. Oh, this is extremely annoying. Sometimes it will autosave and not only move your image, but it will also select your cursor. So I'm now flooding areas that shouldn't be flooded. So to undo that, just click and then hit the undo button. That is a update that I definitely need to get, because this version of Paint, WorldPainter, is not doing it for me. Okay, so where was I? Oh yeah, we have the Ohio. That runs into the, there's a special river that we got along with this. Looks like Scioto. So this is the Scioto River going up here. Then we've got the New River, which goes pretty much down to the bottom of the map here. And then above here we've got the Ohio River continuing inland. And then it splits to the Allegheny up here. And I know I'm mispronouncing this. It's like Monongahela or something like that. Not familiar with the name. And the Youghiogheny, which I know is correct. Which puts Pittsburgh right here. So you know what, I'm going to try and clean this up a little bit so it's not, doesn't look fake here. So what we're going to do is add or below 94 and see what we can, oh yeah, that looks much better. And so you don't have backwards flowing water. Once you say at or below a certain level, you have to continue that all the way upstream until it stops applying. Okay, that looks much better. Let's see. So the Liberty Tunnel will go right through this. Perfect. Perfect. All right. Okay, there's a way to disable auto-saving, but I really don't like to do it. It's just risky. By the way, this bar here represents the memory, and if you run into the end, you're done with the world. You can't do anything with it. So if you create the world and you notice your memory's high, you're not going to be able to do much in the way of like creating rivers and whatnot. Saving, closing, and reopening helps eliminate some of the memory, but not all of it. Okay, so we've got our rivers here. I'm going to continue doing the slew of Chesapeake Bay rivers, probably starting from the southern end because those rivers are larger, and working my way up. Okay, so finally I've got just about all the rivers done. I forgot one very important river in river system. So don't worry, people of the East. Okay, so I added the Delaware, which I had forgotten, and even portions of the Schuylkill, because it looked important. So now we have an interesting feature at the very northern end of the map. It is the Finger Lakes, which are a set of glacial moraine lakes, which were essentially filled river valleys when the glaciers melted. And when the glaciers melted, they had pushed a great amount of debris, which prevented the lakes from draining into the Mohawk River Valley, which is the way they used to drain, and then out through the Hudson. So those river valleys have thus filled with water, and it's pretty cool to see that. Also added a few other reservoirs here. We've got the whole Ohio River system here in the west, and we've got all our Chesapeake Bay rivers in the east, all flowing in. And they came out pretty nicely, even the smaller ones. Oh, it's doing it again. So if I can find a couple examples here to look at, there's the Shenandoah River, which is right here, and the South Branch Potomac River is pretty cool because it goes up towards Dolly Sods, which is some of the highest areas on the map. The highest area is somewhere down here in the extreme southwest. It's about 230, 240, 250. Okay, that's it right there. 255. So it's pretty much dead south, almost as far south as you can go. Take a look at what that looks like in 3D. You can actually see it. That's what it'll look like. Again, like I said, unrealistically steep, but cool to explore. If I go over here, we should be able to see some rivers snaking through. Now these are going to be really fun to explore once we get the world generated. And I'll just need to check and make sure I got my river gaps right. It is really hard to tell because the mountains are extremely steep, but yeah, that looks pretty good getting through there. Okay, so enough with the rivers. We can spend basically our entire lives trying to get it right. So let's go through a number of things here. In addition to water, you can also add any kind of terrain like grass, sands, stone mixes, cobblestones, netherrack, clay, soul sand, stained clay, snow, stuff like that. We shouldn't have to add any of that because of the way that I set things up. I set them up to be realistic for the region. So, you know, you get clays and other stuff down low, and you get grasses in the middle, and you've got bare dirt higher up. So we shouldn't have to mess around with that. The other thing that you got here is biomes. Now, most of this is okay. Like you'll see there's an auto biome, and that goes to plains. If I turn the biomes back on, so we do deciduous and pine, you should be able to see the gaps now. And what we're going to have to do is we're going to have to fill in this area based on what we see on the satellite image, because everything below whatever this cutoff here is defaulted to grassland because of the amount of crop agriculture and whatnot. And we'll probably have to clean up this area out here too. Alright, so that being said, we'll fix the biomes. We'll also add some more trees in the lower areas a little bit later. You can add annotations if you want, but I kind of find it is it slows me down. And then up here we have a few more tools that you can use that we really didn't. If you screw up, you can always sponge. Like, for example, a lot of times when I was filling the Finger Lakes, I had issues where I would click too high and it would overflow the moraine and spill out into this entire area. And then I would have to sponge it up every time it overran. We have our elevation tools. Now this thing I will do right now. This is changing the spawn point. Right now that is centered in pretty much dead center of the map, the Appalachian Mountains. And we want an area where we can assess very quickly whether or not things work properly. So I think that the best place for us to probably spawn in would be Wilmington, Delaware, because that gives us quick access to the Delaware and the Susquehanna and the Chesapeake Bay to verify that everything looks as it should. These are right around here are some of the hardest areas to get right because of the amount of water involved. The mountains are also relatively difficult, but it's not as important to get that coastline correct. Okay, now it's doing it. It'll do this all the time. It drives me crazy. You have to be careful if you want to do global operations here. So I'll once it stops being ridiculous, I'll try and demonstrate. There we go. So you can fill the entire world with a terrain type, reset things, add a new layer, remove one, invert a layer. I don't have no idea what that does. I haven't really used it before. So yeah, you have all sorts of things. You can even raise and lower the entire dimension. That's really handy. You can rotate the entire dimension. And you can shift it horizontally, essentially perform a translation. I really don't need to do it in this case, and it's going to take more time, so I'm not going to do that. So yeah, that's it. What we're going to have to do now is import a satellite image of the area in order to get the forest right. So what we're going to do now is we're going to save, and then I'm going to open up a good program that I can use, like Google Earth, to extract a new background image. Okay. Once you've got your system, then what you're going to want to do is go to View, Configure View, and we're going to have to add another image overlay, unfortunately. So just go ahead and load that. And chances are, unless you're really good with it, you didn't get it 100% correct. So now what you're going to have to do is figure out the scale and positioning for it. So to get the position to go in correctly, you're going to have to do an X offset and a Y offset. And you're going to have to keep fooling with these parameters until you see the maps line up. So I'm going to play around with this for a little bit. Okay, so once you get the positioning correct, you're then ready to begin filling in the various trees and whatnot. So we decided that under 94, we wouldn't be adding any forests. So we need to select the at or below 94, and then what we're going to do is choose deciduous to get a deciduous forest added. And basically what you want to do is you want to vary the intensity. Obviously, the higher the intensity, the thicker the forest. So this should also provide an auto biome for us. So for this, we want to use the paint tool. And basically everywhere you see, the forest and whatnot, that's what you're going to paint in. So if I hide this now, we should be able to see. Oh, I'd still have at or below 69 somehow. I think we said 94. There we go. So yeah, everywhere you see forest now, you have to paint in. And this is what takes a little bit of a longer time than other stuff. You don't have to worry about the forest bleeding into the water. Well, maybe you do. I think it's smart enough to know not to place trees in the water, but if you're worried, it might be a good idea to do at or above. That way you don't put anything in the water. So yeah, we're going to be doing this for quite some time. One thing that we should look at is the solar GIS iMaps. So that's going to tell you what type of terrain that you have, because not all the terrain in this wide area is uniform. If I go to landscape, you'll see out here we've got deciduous continuous broadleaf forest. So essentially it's all trees that lose their leaves in the fall. Down here we have mixed forest, which means you're also going to get pine trees. Out here we've got deciduous, and I think we have as far east as Trenton, which means this area is actually going to get straight evergreen. So that's how you do that. In some of these places you actually have to take off the at or below. For example, in the Shenandoah Valley, you actually have farms above our cutoff altitude, which means, to be realistic, now you have to start removing trees from the scene. Okay, so this region contains an extremely farmable region right here. So what we're going to do is we're going to remove all the trees from this northwestern area because basically the entire section here is farmed. And final note, aside from the northwestern area, none of this land contains truly treeless areas, not even the northwestern area to the most part. So what you want to do is, in that region, put the intensity down to something very low, like 8 to 10%, and just fill everything else in, aside from, the few areas you can see here where there's basically no trees. Once you think you're done with the biomes, just give it a double check and make sure that the auto biomes populated. They did here, so virtually everything except this Great Valley and the metropolitan areas are forest. The surrounding area is known as plains. Check your map in isometric view just to make sure everything looks the way it should. And then we're going to move on to the final stages. So again, just check and make sure trees are where they're supposed to be. Make sure that the mountains look fairly reasonable and aren't out of control. This is borderline crazy, but it should look really cool when walking around here, and it should make things quite challenging. The mountains will really be barriers, so it will actually challenge us to find passes to get through these. It's going to be a little bit interesting. You can't save it too many times. It's already kind of driving me problems with the frame rate. So the next thing, because we bypassed the frost section, we get to add caverns and chasms. So what I like to do, the theme that I like, is caverns everywhere, but underground chasms only in the mountains. For this, I highly recommend, if you want them in certain places, turn your intensity all the way up and use a constant circle. That'll prevent, there being half chasms and half caverns and that kind of thing. So I'm just going to start highlighting this stuff up. And unfortunately, the caverns that WorldPainter simulates, at least the ones that were in an earlier version that I had, it was like 1.7. I'm not sure if they've updated it. They're not really realistic. Those caverns are more cartoonish. They're kind of ovular clusters and small chambers and round rooms. There's not very much in the way of consistency, unfortunately. So that's a little bit unfortunate. Oh yeah, for this, if you want caverns underneath the water, which I certainly do, make sure you disable the at or below and at or above. You want this stuff everywhere. That is what you want to see. Wow, my computer is really trashed right now. When in doubt, just hit the giant paint bucket and it'll take care of everything. For this, I decided that we're going to have the chasm start at 2,000 feet, which is 128. So for this, what we're going to do is we're going to do at or above 128. And that will limit the chasms to areas that are only above 2,000 feet in elevation. Okay, so here's what the chasms layer looks like when it's done. So we have a clustering up in the north and then a stripe going southwards. Okay, perhaps the last thing to do is to add the underground layers, specifically the bedrocks. And before you do that, you're going to want to turn all these layers off so that you can see what you're doing. So whatever we filled in, go ahead and turn off. And what we're going to do is we're going to bring up a website which shows the bedrocks of this region, and then we're going to fill them in. This USGS website provides a adequate base for our bedrock. We are going to be going quite far into the earth. Remember, I had said that we had set level 60, 69 as sea level, and if you do the math, what you find is that the 0 mark is 2,000 feet below sea level. So in the case of the highest mountains, we can be going to scale about 4,000 feet below the surface. So in some cases, that actually pierces the bedrock. The coastal plain bedrock is only a few thousand feet thick, and then it transitions to generally what you find upland. So we're going to go ahead and start filling those in. The first and easiest one is probably the outer one here. So what you want to do is you want to find about where things are centrally located, and then just go ahead and click and see what you get. So then you've got lowland, upland, and this formation. So these formations are quaternary, which means they're going to be younger and they're going to be higher up. So what that also means is that they're going to be thinner because a quaternary is a shorter time span. So that altitude range will already be covered by the surface layer of dirt and grass in Minecraft. It's going to be about 3 to 4 meters, which corresponds with I really need to get that scale down. So we start at let's see, 255 is going to be 5,700. Sea level is going to be 69, which means negative 2,000 should be 0. So let's go ahead and do that real quick. So if we do 5,700 divided by that subtraction, so we get each meter in Minecraft represents 30 feet in elevation. So now if we multiply here, negative 69 times 30, we should get about 2,000. Okay, 2114. So yeah, each one represents 30 feet. So what we're going to do instead is go with the Miocene formation. And what we're going to do here is just look at what we can see. Unconsolidated sand, fine sand. This is what's really important here. Embedded dark green to dark bluish clay. Fine grained sand and clay, shell beds, etc. Greenish blue. Yeah, the formation is a greenish blue clay. So what we're going to do now is we're going to click the plus button and do add underground pockets layer right here, and we're going to choose terrain, and we're going to pick I guess it's not included in terrain, so we're going to have to go to custom material, add a custom material, and what we want to look for is a stained clay, not terracotta, actual clay. Okay, well, it looks like the name has actually been changed. Yeah, it looks like the item ID may have changed as well, which might also cause another issue. Alright, so what we're going to do over here, because there's two constituents, we're going to add 2 blocks. So the first one is going to be, we'll go with light blue. If that'll actually show up. It's not showing up for some reason. Light blue is probably the closest. There we go. And now we're going to add a second material, and we're going to make this one sand. And what that should make is a matrix which closely resembles it. Okay, so the next thing we're going to do is name this. So if we go back to the site here, we can rename this. And just so that it shows up the way it does here, we're going to recolor this to be a very light yellow. And now it should match. So what we're going to go ahead and do is click OK. And then we have a custom material here. Its name has been imported here. Its color's been imported. All we now to do is change the occurrence, and that's per mil, which means 1,000 is max. So we're going to go ahead and actually max that out. We want 100 or 1,000 per mil rather. So the entire underground is that color. Scale doesn't apply once you go to full or void. And next we're going to adjust the levels. So what we'll do here is, because I know there's a transition under here at about well, it's actually below the level of the bottom of our world. Okay, and then the maximum level is simply where the fall line is going to be. So what we need to do is find the altitude of the fall line, and then we should be able to just fill it in, and it should look really good once I do that. Okay, so you click OK, and you get this new material. So now the next thing we need to do is set at or below 76, and then we're going to add the constant circle for the total presence, and paint, and we should get a good good deposit. Now for some reason that's disabled itself. I want to force at or below 76. Perfect. So that's what it's going to look like when we start adding it, and it's just going to cover this entire region right here, and then we'll move on to these next ones. And it did its autosave thing again. Okay, so here is the completed layer when you compare it with the website. Pretty close. So what we're going to do now is repeat the exact same process for every single major unit. I'm only going to pick the major ones because if we go for the little ones, we'll be here forever. So I found a location that should be basalt, and Minecraft doesn't have a basalt rock. So in this case, I'm actually going to substitute it using stone. I'm on to the last formation now, so to make sure that it doesn't interfere with what's already there, this is the first time I'm using the accept on, and I'm going to choose the Beekmantown group. That way, it will prevent this from getting into the area where that covers. So I'm just going to do this, and I'm going to avoid this area, and then I'm going to select the Washington formation. Okay, I've turned all the layers back on and saved. So this is the world as it will be exported to Minecraft. So if I go ahead and disable the caverns and chasms, you can now see pretty much our entire underlying rock structure here that I've added. I do need to check something else though, so that the chasms will disappear from view. Sometimes this thing is a bit buggy. There we go. So these are all the different rock formations. I've largely left the stone section in the Appalachian Mountains untouched because it's crystalline anyway, and it's generally unconsolidated crystalline rock. So the Minecraft stone is a good approximation of that. So now this is where things start to get really serious. We're going to do File, Export, Export as New Minecraft Map. Alright, so this is what you'll get when it comes up. So right now we only have one dimension. If you had other dimensions added, you would get these options here. So when you set the top layer minimum depth, that's the depth of the grass or rock or whatever covers the surface. Normally in Minecraft it's 3 to 7, but in this case I'm actually going to turn it down to 3 because each meter represents 90 feet. And we've painted rivers in the surface material. So in order to prevent all the rivers from being deep channels that are several hundred meters deep, I'm going to limit it to 3, which makes it somewhat more realistic. Keep steep terrain covered will basically prevent the underground formations from being exposed. And I actually want to disable that because you want to be able to see underneath the different rocks and whatnot. So I'm actually going to disable that. Right now, the layered materials are relative to bedrock. I'm actually not sure what happens if you change them relative to terrain, because I haven't really experimented with that before. Underground material, I guess I get to choose what we have underneath, but there's no real good choice in our case. I mean, basically the only thing that we've left just bare underground material is the Appalachian Mountains. We're just actually going to go with rock, which will give us a unconsolidated kind of cobblestone stone mix. If you do bottomless world, you won't have bedrock, which we don't want. You can also add a border of water, which will prevent the outside from being visible, which is preferred. The water or lava level is extremely important. Remember, I said that 69 was sea level. If we change this, it's going to affect the world. So we could lower it, and that would simulate an ice age, and we could raise it, and that would simulate the Mesozoic. We don't want a bedrock wall at the edge of the map, because that will look messy. You'll see it everywhere. The seed doesn't matter. I'm going to disable the chest of goodies because I don't want extra stuff there. I'll do generally creative. Well, actually, I think I do survival and allow cheats. This will allow me to fix anything that may be broken, such as any water gaps that I still don't like. Generally, I want to go with large biomes for the world type, because the different biomes that we have are rather large as compared with normal Minecraft ones, so I'm doing large. Probably a good idea to disable structures, because you're going to see all sorts of weird stuff everywhere. Sometimes it's fun just to see what it'll generate, and sometimes it'll be good, but it's probably going to take me about 9 hours to generate this map, so I really don't want to do that sort of thing. You always want Minecraft 1.2 or later if you want to play on Minecraft 1.2 or later. Otherwise, that. If you want to export the whole map, just do export everything. For chasms and caverns, you don't need to check these check marks because we've already hand painted. You can also pick the minimum and maximum values of the caves, which are totally fine. I'm not going to increase or decrease these. You can also flood them at a lower level, which I actually might do, because that's realistic in this area. So we'll go down to about level 16, and then I'll have them flooded below that. Don't do caverns and chasms break the surface, because the caves in this editor do not generate properly. They generate these extremely large, open, bowl-like craters. So if you do that, you essentially won't be able to walk, because the area will be so mountainous and be open to the bottom. It's a mess. So I suggest not doing that. For resources, I generally leave resources everywhere. That will allow areas to appear. Let's see, if I do populate terrain, it slows down generation of the world, and it will allow Minecraft seed to control certain things, so I kind of don't like that. For custom layers, we can choose what goes first and things will begin to override. So generally the way that things work around here is the older materials will be laid down first, followed by newer materials. So what we're going to do is we're going to find the oldest, which is that should be Beekman Town, followed by Conemaugh, and then Norbeck, Washington, and the youngest is going to be Chesapeake. So basically what that will do is that will lay down the oldest deposits first and then start covering the newer deposit, or the older deposits, with the new deposits, which is how the Earth's rock cycle works. Okay, that is it. So now all we need to do is click export, and then it's going to take me 9 hours to do that. Okay, so this is it. This is what it all comes down to. After opening Minecraft, you basically need to choose your... Well, yeah, after opening the launcher, you need to pick the version of Minecraft that you want to open the world up with. Now, before you open the world, this is very important. You must copy the file that you made, or you're going to have an issue with potential... You could have the potential for block mismatches. So what's wood turns out to be stone, and what stone turns out to be something like netherrack, or even worse, something like fence posts. So this is extremely important. Now, one thing that I like about the recent WorldPainter is its speed. It only took 20 minutes to build this world, and it claims to have laid 4 billion blocks, which is about, sounds right. So here we go. Okay, unfortunately, I took a look around, and I can only find rock. I can't find the Conemaugh Formation, which is an extremely big problem. So I need to see exactly what the deal with that is about. Because we should have a mixture of materials here. Okay, and we've got it. So what happened, it took me about 3 or 4 attempts to figure out exactly what was going on. Unfortunately, Minecraft decided to change its block IDs, and that really threw my world generation system for a loop. Basically, it prevented the world from generating properly, and what ended up happening was the blue stained clay is part of the Chesapeake Formation was not appearing, and the sand, which I forgot encounters gravity in Minecraft, is not held in by any sort of structure, and therefore it's allowed to collapse into the caverns. So what I had to do is I had to change the Chesapeake Formation to be a mix of sandstone and the regular old clay, like this kind. And it's not perfect, but I mean, it kind of works. I think I also put some mossy cobblestone in there or something. But yeah, that's basically what ended up happening to it. I had to fix some other formations as well. I'm thinking what we're going to do is we're going to jump up to
tried sticking this into 1.8, and if 1.8 doesn't crash, then upgrade to Optifine with shaders. Okay, so to load it, just go to single player, find the name of your world. It'll come up the way you saved it. I've changed the name a little bit, and hit play. And we'll take a look here. Okay, so I've done a little bit in this world so far just to make sure it was going to work, and we have an adequate world. That was Kent Island in the Chesapeake Bay, and basically what we're going to do is we're going to take a look and make sure everything is as it should be, and if it's acceptable, we'll give you a nice little tour, and that's how we will close. Everything looks good with the Chesapeake Bay. We'll check the Delaware Bay. Particularly, I'm interested in the portion where it goes from not sea level to sea level, which is right here, because it's the overground material, right here. Amazing, seamless. So this is the tidal portions of the Delaware Bay, and this is the non-tidal portions of the Delaware River. Everything looks good. So the last thing that we need to check now is the underground. So for that, we're going to prepare some material to repair what we're going to try and do. Okay, let's see what we got. Okay, we've just hit a cavern layer. And so now what we're going to need to do is oh, we're at 16, so this is basically the bottom of the world here. This is level 8. So everything looks good. Done. Okay, so now what we're going to do is transition to a silent tour. We're going to go to resource packs, activate my Chroma Hills 6, and we're going to turn shaders on, which should make my room nice and warm, which is good because it's very cold outside. And the next thing is video settings, shaders. And now this is where everything. And welcome to the real world. That should be southeast. Good. Everything is as it should be. So we will start a tour.
close this tutorial at a site of another one of my Minecraft worlds, Chestnut Ridge. Thank you for joining me, and hopefully this tutorial, although long, has been very helpful. This is the apex of what you can get using that kind of procedure. Thank you guys for joining me, and I will see you guys next time. Bye-bye.